A company runs a proprietary stateless ETL application on an Amazon EC2 Linux instances. The application is a Linux binary, and the source code cannot be modified. The application is single-threaded, uses 2 GB of RAM, and is highly CPU intensive. The application is scheduled to run every 4 hours and runs for up to 20 minutes. A solutions architect wants to revise the architecture for the solution. Which strategy should the solutions architect use? A. Use AWS Lambda to run the application. Use Amazon CloudWatch logs to invoke the Lambda function every 4 hours. B. Use AWS Batch to run the application. Use an AWS Step Functions state machine to invoke the AWS Batch job every 4 hours. C. Use AWS Fargate to run the application. Use Amazon Event Bridge, Amazon CloudWatch events, to invoke the Fargate task every 4 hours. D. Use Amazon EC2 Spot instances to run the application. Use AWS Code Deploy to deploy and run the application every 4 hours. A company runs many workloads on AWS and uses AWS organizations to manage its accounts. The workloads are hosted on Amazon EC2, AWS Fargate, and AWS Lambda. Some of the workloads have unpredictable demand. Accounts record high usage in some months and low usage in other months. The company wants to optimize its compute costs over the next 3 years. A solutions architect obtains a 6-month average for each of the accounts across the organization to calculate usage. Which solution will provide the most cost savings for all the organization's compute usage? A. Purchase reserved instances for the organization to match the size and number of the most common EC2 instances from the member accounts. B. Purchase a compute savings plan for the organization from the management account by using the recommendation at the management account level. C. Purchase reserved instances for each member account that had high EC2 usage according to the data from the last 6 months. D. Purchase an EC2 instance savings plan for each member account from the management account based on EC2 usage data from the last 6 months. A company is running an application in the AWS cloud. The company's security team must approve the creation of all new IAM users. When a new IAM user is created, all access for the user must be removed automatically. The security team must then receive a notification to approve the user. The company has a multi-region AWS CloudTrail trail in the AWS account. Which combination of steps will meet these requirements? Choose 3. A. Create an Amazon Event Bridge, Amazon CloudWatch Events, rule. Define a pattern with the detail type value set to AWS API call via CloudTrail and an event name of create user. B. Configure CloudTrail to send a notification for the create user event to an Amazon Simple Notification Service, Amazon SNS topic. C. Invoke a container that runs in Amazon Elastic Container Service, Amazon ECS, with AWS Fargate technology to remove access. D. Invoke an AWS Step Functions state machine to remove access. E. Use Amazon Simple Notification Service, Amazon SNS, to notify the security team. F. Use Amazon Pinpoint to notify the security team. A weather service provides high-resolution weather maps from a web application hosted on AWS in the EU West 1 region. The weather maps are updated frequently and stored in Amazon S3, along with static HTML content. The web application is fronted by Amazon CloudFront. The company recently expanded to serve users in the US East 1 region, and these new users report that viewing their respective weather maps is slow from time to time. Which combination of steps will resolve the US East 1 performance issues? Choose 2. A. Configure the AWS Global Accelerator endpoint for the S3 bucket in EU West 1. Configure endpoint groups for TCP ports 80 and 443 in US East 1. B. Create a new S3 bucket in US East 1. Configure S3 cross-region replication to synchronize from the S3 bucket in EU West 1. C. Use Lambda at Edge to modify requests from North America to use the S3 transfer acceleration endpoint in US East 1. D. Use Lambda at Edge to modify requests from North America to use the S3 bucket in US East 1. E. Configure the AWS Global Accelerator endpoint for US East 1 as an origin on the CloudFront distribution. Use Lambda at Edge to modify requests from North America to use the new origin. A company is planning to host a web application on AWS and wants to load balance the traffic across a group of Amazon EC2 instances. One of the security requirements is to enable end-to-end encryption in transit between the client and the web server. Which solution will meet this requirement? A. Place the EC2 instances behind an application load balancer. ALB. Provision an SSL certificate using AWS Certificate Manager ACM and associate the SSL certificate with the ALB. Export the SSL certificate and install it on each EC2 instance. Configure the ALB to listen on port 443 and to forward traffic to port 443 on the instances. B. Associate the EC2 instances with a target group. Provision an SSL certificate using AWS Certificate Manager ACM. Create an Amazon CloudFront distribution and configure it to use the SSL certificate. Set CloudFront to use the target group as the origin server. C. Place the EC2 instances behind an application load balancer ALB. Provision an SSL certificate using AWS Certificate Manager ACM and associate the SSL certificate with the ALB. Provision a third-party SSL certificate and install it on each EC2 instance. Configure the ALB to listen on port 443 and to forward traffic to port 443 on the instances. D. Place the EC2 instances behind a network load balancer NLB. Provision a third-party SSL certificate and install it on the NLB and on each EC2 instance. Configure the NLB to listen on port 443 and to forward traffic to port 443 on the instances. A company runs an IoT platform on AWS. IoT sensors in various locations send data to the company's Node. JS API servers on Amazon EC2 instances running behind an application load balancer. The data is stored in an Amazon RDS MySQL DB instance that uses a 4 TB general-purpose SSD volume. The number of sensors the company has deployed in the field has increased over time and is expected to grow significantly. The API servers are consistently overloaded and RDS metrics show high write latency. Which of the following steps together will resolve the issues permanently and enable growth as new sensors are provisioned, while keeping this platform cost-efficient? Choose 2. A. Resize the MySQL general-purpose SSD storage to 6 TB to improve the volume's IOPS. B. Re-architect the database tier to use Amazon Aurora instead of an RDS MySQL DB instance and add read replicas. C. Leverage Amazon Kinesis data streams and AWS Lambda to ingest and process the raw data. B. Use AWS X-Ray to analyze and debug application issues and add more API servers to match the load. E. Re-architect the database tier to use Amazon DynamoDB instead of an RDS MySQL DB instance. An application is using an Amazon RDS for a MySQL multi-AZ DB instance in the US East 1 region. After a failover test, the application lost the connections to the database and could not re-establish the connections. After a restart of the application re-established the connections. A solutions architect must implement a solution so that the application can re-establish connections to the database without requiring a restart. Which solution will meet these requirements? A. Create an Amazon Aurora MySQL Serverless v1 DB instance. Migrate the RDS DB instance to the Aurora Serverless v1 DB instance. Update the connection settings in the application to point to the Aurora Reader endpoint. B. Create an RDS proxy. Configure the existing RDS endpoint as a target. Update the connection settings in the application to point to the RDS proxy endpoint. C. Create a 2-node Amazon Aurora MySQL DB cluster. Migrate the RDS DB instance to the Aurora DB cluster. Create an RDS proxy. Configure the existing RDS endpoint as a target. Update the connection settings in the application to point to the RDS proxy endpoint. D. Create an Amazon S3 bucket. Export the database to Amazon S3 by using AWS Database Migration Service, AWS DMS. Configure Amazon Athena to use the S3 bucket as a data store. Install the latest Open Database Connectivity (ODBC) driver for the application. Update the connection settings in the application to point to the Athena endpoint. A company is hosting a 3-tier web application in an on-premises environment. Due to a recent surge in traffic that resulted in downtime and a significant financial impact, company management has ordered that the application be moved to AWS. The application is written in .NET and has a dependency on a MySQL database. A solutions architect must design a scalable and highly available solution to meet the demand of 200,000 daily users. Which steps should the solutions architect take to design an appropriate solution? A. Use AWS Elastic Beanstalk to create a new application with a web server environment and an Amazon RDS MySQL multi-AZ DB instance. The environment should launch a Network Load Balancer (NLB) in front of an Amazon EC2 autoscaling group in multiple availability zones. Use an Amazon Route 53 alias record to route traffic from the company's domain to the NLB. B. Use AWS CloudFormation to launch a stack containing an Application Load Balancer (ALB) in front of an Amazon EC2 autoscaling group spanning 3 availability zones. The stack should launch a multi-AZ deployment of an Amazon Aurora MySQL DB cluster with a retain deletion policy. Use an Amazon Route 53 alias record to route traffic from the company's domain to the ALB. C. Use AWS Elastic Beanstalk to create an automatically scaling web server environment that spans 2 separate regions with an Application Load Balancer (ALB) in each region. Create a multi-AZ deployment of an Amazon Aurora MySQL DB cluster with a cross-region read replica. Use Amazon Route 53 with a geo-proximity routing policy to route traffic between the 2 regions. A. Use AWS CloudFormation to launch a stack containing an Application Load Balancer (ALB) in front of an Amazon ECS cluster of Spot instances spanning 3 availability zones. The stack should launch an Amazon RDS MySQL DB instance with a snapshot deletion policy. Use an Amazon Route 53 alias record to route traffic from the company's domain to the ALB. A company needs to migrate its website from an on-premises data center to AWS. The website consists of a load balancer, a content management system, CMS, that runs on a Linux operating system, and a MySQL database. The CMS requires persistent NFS-compatible storage for a file system. The new solution on AWS must be able to scale from 2 Amazon EC2 instances to 30 EC2 instances in response to unpredictable traffic increases. The new solution also must require no changes to the website and must prevent data loss. Which solution will meet these requirements? A. Create an Amazon Elastic File System, Amazon EFS, file system. Deploy the CMS to AWS Elastic Beanstalk with an application load balancer and an auto-scaling group. Use TH, EB extensions to mount the EFS file system to the EC2 instances. Create an Amazon Aurora MySQL database that is separate from the Elastic Beanstalk environment. B. Create an Amazon Elastic Block Store, Amazon EBS, multi-attach volume. Deploy the CMS to AWS Elastic Beanstalk with a network load balancer and an auto-scaling group. Use PitchPoint, EB extensions to mount the EBS volume to the EC2 instances. Create an Amazon RDS for MySQL database in the Elastic Beanstalk environment. C. Create an Amazon Elastic File System, Amazon EFS file system. Create a launch template and an auto-scaling group to launch EC2 instances to support the CMS. Create a network load balancer to distribute traffic. Create an Amazon Aurora MySQL database. Use an EC2 auto-scaling scale-in lifecycle hook to mount the EFS file system to the EC2 instances. D. Create an Amazon Elastic Block Store, Amazon EBS, multi-attach volume. Create a launch template and an auto-scaling group to launch EC2 instances to support the CMS. Create an application load balancer to distribute traffic. Create an Amazon Elasticache for Redis cluster to support the MySQL database. Use EC2 user data to attach the EBS volume to the EC2 instances. An online survey company runs its application in the AWS cloud. The application is distributed and consists of microservices that run in an automatically scaled Amazon Elastic Container Service, Amazon ECS cluster. The ECS cluster is a target for an application load balancer, ALB. The ALB is a custom origin for an Amazon CloudFront distribution. The company has a survey that contains sensitive data. The sensitive data must be encrypted when it moves through the application. The application's data handling microservice is the only microservice that should be able to decrypt the data. Which solution will meet these requirements? A. Create a symmetric AWS key management service, AWS KMS key, that is dedicated to the data handling microservice. Create a field-level encryption profile and a configuration. Associate the KMS key and the configuration with the CloudFront cache behavior. B. Create an RSA key pair that is dedicated to the data handling microservice. Upload the public key to the CloudFront distribution. Create a field-level encryption profile and a configuration. Add the configuration to the CloudFront cache behavior. C. Create a symmetric AWS key management service, AWS KMS key, that is dedicated to the data handling microservice. Create a Lambda at Edge function. Program the function to use the KMS key to encrypt the sensitive data. B. Create an RSA key pair that is dedicated to the data handling microservice. Create a lambda at edge function. Program the function to use the private key of the RSA key pair to encrypt the sensitive data. A company runs an IoT application in the AWS cloud. The company has millions of sensors that collect data from houses in the United States. The sensors use the MQTT protocol to connect and send data to a custom MQTT broker. The MQTT broker stores the data on a single Amazon EC2 instance. The sensors connect to the broker through the domain named iot.example.com. The company uses Amazon Route 53 as its DNS service. The company stores the data in Amazon DynamoDB. On several occasions, the amount of data has overloaded the MQTT broker and has resulted in lost sensor data. The company must improve the reliability of the solution. Which solution will meet these requirements? A. Create an application load balancer, ALB, and an autoscaling group for the MQTT broker. Use the autoscaling group as the target for the ALB. Update the DNS record in Route 53 to an alias record. Point the alias record to the ALB. Use the MQTT broker to store the data. B. Set up AWS IoT Core to receive the sensor data. Create and configure a custom domain to connect to AWS IoT Core. Update the DNS record in Route 53 to point to the AWS IoT Core Data ATS endpoint. Configure an AWS IoT rule to store the data. C. Create a network load balancer, NLB. Set the MQTT broker as the target. Create an AWS Global Accelerator. Set the NLB as the endpoint for the accelerator. Update the DNS record in Route 53 to a multi-value answer record. Set the global accelerator IP addresses as values. Use the MQTT broker to store the data. D. Set up AWS IoT Greengrass to receive the sensor data. Update the DNS record in Route 53 to point to the AWS IoT Greengrass endpoint. Configure an AWS IoT rule to invoke an AWS Lambda function to store the data. A company is using GitHub Actions to run a CI/CD pipeline that accesses resources on AWS. The company has an IAM user that uses a secret key in the pipeline to authenticate to AWS. An existing IAM role with an attached policy grants the required permissions to deploy resources. The company's security team implements a new requirement that pipelines can no longer use long-lived secret keys. A solutions architect must replace the secret key with a short-lived solution. Which solution will meet these requirements with the least operational overhead? A. Create an IAM SAML 2.0 Identity Provider, IDP, in AWS Identity and Access Management, IAM. Create a new IAM role with the appropriate trust policy that allows the STS assume role API call. Attach the existing IAM policy to the new IAM role. Update GitHub to use SAML authentication for the pipeline. B. Create an IAM OpenID Connect, OIDC Identity Provider, IDP, in AWS Identity and Access Management, IAM. Create a new IAM role with the appropriate trust policy that allows the STS assume role with Web Identity API call from the GitHub OIDLU IDP. Update GitHub to assume the role for the pipeline. C. Create an Amazon Cognito Identity Pool. Configure the authentication provider to use GitHub. Create a new IAM role with the appropriate trust policy that allows the STS assume role with Web Identity API call from the GitHub authentication provider. Configure the pipeline to use Cognito as its authentication provider. D. Create a trust anchor to AWS Private Certificate Authority. Generate a client certificate to use with AWS IAM roles anywhere. Create a new IAM role with the appropriate trust policy that allows the STS assume role API call. Attach the existing IAM policy to the new IAM role. Configure the pipeline to use the credential helper tool and to reference the client certificate public key to assume the new IAM role. A company is deploying a new API to AWS. The API uses Amazon API Gateway with a regional API endpoint and an AWS Lambda function for hosting. The API retrieves data from an external vendor API, stores data in an Amazon DynamoDB global table, and retrieves data from the DynamoDB global table. The API key for the vendor's API is stored in AWS Secrets Manager and is encrypted with a customer-managed key in AWS Key Management Service. AWS. The company has deployed its own API into a single AWS region. A solutions architect needs to change the API components of the company's API to ensure that the components can run across multiple regions in an active configuration. Which combination of changes will meet this requirement with the least operational overhead? Choose 3. A. Deploy the API to multiple regions. Configure Amazon Route 53 with custom domain names that route traffic to each regional API endpoint. Implement a Route 53 multi-value answer routing policy. B. Create a new KMS multi-region customer managed key. Create a new KMS customer managed replica key in each in-scope region. C. Replicate the existing Secrets Manager secret to other regions. For each in-scope region's replicated secret, select the appropriate KMS key. D. Create a new AWS managed KMS key in each in-scope region. Convert an existing key to a multi-region key. Use the multi-region key in other regions. E. Create a new Secrets Manager secret in each in-scope region. Copy the secret value from the existing region to the new secret in each in-scope region. F. Modify the deployment process for the Lambda function to repeat the deployment across in-scope regions. Turn on the multi-region option for the existing API. Select the Lambda function that is deployed in each region as the backend for the multi-region API. A company runs a software as a service (SaaS) application on AWS. The application consists of AWS Lambda functions and an Amazon RDS for MySQL multi-AZ database. During market events, the application has a much higher workload than normal. Users notice slow response times during the peak periods because of many database connections. The company needs to improve the scalable performance and availability of the database. Which solution meets these requirements? A. Create an Amazon CloudWatch alarm action that triggers a Lambda function to add an Amazon RDS for MySQL read replica when resource utilization hits a threshold. B. Migrate the database to Amazon Aurora and add a read replica. Add a database connection pool outside of the Lambda handler function. C. Migrate the database to Amazon Aurora and add a read replica. Use Amazon Route 53 weighted records. D. Migrate the database to Amazon Aurora and add an Aurora replica. Configure Amazon RDS proxy to manage database connection pools. A company is using AWS Control Tower to manage AWS accounts in an organization in AWS organizations. The company has an OU that contains accounts. The company must prevent any new or existing Amazon EC2 instances in the OU's accounts from gaining a public IP address. Which solution will meet these requirements? A. Configure all instances in each account in the OU to use AWS Systems Manager. Use a Systems Manager automation runbook to prevent public IP addresses from being attached to the instances. B. Implement the AWS Control Tower proactive control to check whether instances in the OU's accounts have a public IP address. Set the associate public IP address property to false. Attach the proactive control to the OU. C. Create an SCP that prevents the launch of instances that have a public IP address. Additionally, configure the SCP to prevent the attachment of a public IP address to existing instances. Attach the SCP to the OU. B. Create an AWS config custom rule that detects instances that have a public IP address. Configure a remediation action that uses an AWS Lambda function to detach the public IP addresses from the instances. A company has many AWS accounts and uses AWS organizations to manage all of them. A solutions architect must implement a solution that the company can use to share a common network across multiple accounts. The company's infrastructure team has a dedicated infrastructure account that has a VPC. The infrastructure team must use this account to manage the network. Individual accounts cannot have the ability to manage their own networks. However, individual accounts must be able to create AWS resources within subnets. Which combination of actions should the solutions architect perform to meet these requirements? Choose 2. A. Create a transit gateway in the infrastructure account. B. Enable resource sharing from the AWS Organizations Management account. C. Create VPCs in each AWS account within the organization in AWS organizations. Configure the VPCs to share the same CIDR range and subnets as the VPC in the infrastructure account. Peer the VPCs in each individual account with the VPC in the infrastructure account. B. Create a resource share in AWS Resource Access Manager in the infrastructure account. Select the specific AWS organization's OU that will use the shared network. Select each subnet to associate with the resource share. E. Create a resource share in AWS Resource Access Manager in the infrastructure account. Select the specific AWS organization's OU that will use the shared network. Select each prefix list to associate with the resource share. A company needs to store and process image data that will be uploaded from mobile devices using a custom mobile app. Usage peaks between 8 a.m. and 5 p.m. on weekdays, with thousands of uploads per minute. The app is rarely used at any other time. A user is notified when image processing is complete. Which combination of actions should a solutions architect take to ensure image processing can scale to handle the load? Choose 3. A. Upload files from the mobile software directly to Amazon S3. Use S3 event notifications to create a message in an Amazon MQ queue. B. Upload files from the mobile software directly to Amazon S3. Use S3 event notifications to create a message in an Amazon Simple Queue service, Amazon SQS Standard Queue. C. Invoke an AWS Lambda function to perform image processing when a message is available in the queue. D. Invoke an S3 batch operations job to perform image processing when a message is available in the queue. E. Send a push notification to the mobile app by using Amazon Simple Notification Service, Amazon SNS, when processing is complete. F. Send a push notification to the mobile app by using Amazon Simple Email Service, Amazon SES, when processing is complete. A solutions architect is auditing the security setup, or an AWS Lambda function for a company. The Lambda function retrieves the latest changes from an Amazon Aurora database. The Lambda function and the database run in the same VPC. Lambda environment variables are providing the database credentials to the Lambda function. The Lambda function aggregates data and makes the data available in an Amazon S3 bucket that is configured for server-side encryption with AWS KMS Managed Encryption Keys, SSEKMS. The data must not travel across the internet. If any database credentials become compromised, the company needs a solution that minimizes the impact of the compromise. What should the solutions architect recommend to meet these requirements? A. Enable IAM database authentication on the Aurora DB cluster. Change the IAM role for the Lambda function to allow the function to access the database by using IAM database authentication. Deploy a gateway VPC endpoint for Amazon S3 in the VPC. B. Enable IAM database authentication on the Aurora DB cluster. Change the IAM role for the Lambda function to allow the function to access the database by using IAM database authentication. Enforce HTTPS on the connection to Amazon S3 during data transfers. C. Save the database credentials in AWS Systems Manager Parameter Store. Set up password rotation on the credentials in Parameter Store. Change the IAM role for the Lambda function to allow the function to access Parameter Store. Modify the Lambda function to retrieve the credentials from Parameter Store. Deploy a gateway VPC endpoint for Amazon S3 in the VPC. D. Save the database credentials in AWS Secrets Manager. Set up password rotation on the credentials in Secrets Manager. Change the IAM role for the Lambda function to allow the function to access Secrets Manager. Modify the Lambda function to retrieve the credentials from Secrets Manager. Enforce HTTPS on the connection to Amazon S3 during data transfers. A company wants to migrate its website to AWS. The website uses microservices and runs on containers that are deployed in an on-premises, self-managed Kubernetes cluster. All the manifests that define the deployments for the containers in the Kubernetes deployment are in source control. All data for the website is stored in a PostgreSQL database. An open-source container image repository runs alongside the on-premises environment. A solutions architect needs to determine the architecture that the company will use for the website on AWS. Which solution will meet these requirements with the least effort to migrate? A. Create an AWS App Runner service. Connect the App Runner service to the open-source container image repository. Deploy the manifests from on-premises to the App Runner service. Create an Amazon RDS for PostgreSQL database. B. Create an Amazon Elastic Kubernetes service, Amazon EKS cluster that has managed node groups. Copy the application containers to a new Amazon Elastic Container Registry, Amazon ECR repository. Deploy the manifests from on-premises to the EKS cluster. Create an Amazon Aurora PostgreSQL DB cluster. C. Create an Amazon Elastic Container Service, Amazon ECS cluster that has an Amazon EC2 capacity pool. Copy the application containers to a new Amazon Elastic Container Registry, Amazon ECR repository. Register each container image as a new task definition. Configure ECS services for each task definition to match the original Kubernetes deployments. Create an Amazon Aurora PostgreSQL DB cluster. D. Rebuild the on-premises Kubernetes cluster by hosting the cluster on Amazon EC2 instances. Migrate the open-source container image repository to the EC2 instances. Deploy the manifests from on-premises to the new cluster on AWS. Deploy an open-source PostgreSQL database on the new cluster. A company has developed an application that is running Windows Server on VMware vSphere VMs that the company hosts on premises. The application data is stored in a proprietary format that must be read through the application. The company manually provisioned the servers and the application. As part of its disaster recovery plan, the company wants the ability to host its application on AWS temporarily if the company's on-premises environment becomes unavailable. The company wants the application to return to on-premises hosting after a disaster recovery event is complete. The RPO is 5 minutes. Which solution meets these requirements with the least amount of operational overhead? A. Configure AWS DataSync. Replicate the data to Amazon Elastic Block Store, Amazon EBS volumes. When the on-premises environment is unavailable, use AWS CloudFormation templates to provision Amazon EC2 instances and attach the EBS volumes. B. Configure AWS Elastic Disaster Recovery. Replicate the data to replication Amazon EC2 instances that are attached to Amazon Elastic Block Store, Amazon EBS volumes. When the on-premises environment is unavailable, use Elastic Disaster Recovery to launch EC2 instances that use the replicated volumes. C. Provision an AWS Storage Gateway File Gateway. Replicate the data to an Amazon S3 bucket. When the on-premises environment is unavailable, use AWS Backup to restore the data to Amazon Elastic Block Store, Amazon EBS volumes, and launch Amazon EC2 instances from these EBS volumes. D. Provision an Amazon FSx for Windows File Server file system on AWS. Replicate the data to the file system. When the on-premises environment is unavailable, use AWS CloudFormation templates to provision Amazon EC2 instances, and use AWS CloudFormation init commands to mount the Amazon FSx file shares. A company is planning to migrate an application from on-premises to the AWS cloud. The company will begin the migration by moving the application's underlying data storage to AWS. The application data is stored on a shared file system on premises, and the application servers connect to the shared file system through SMB. A solutions architect must implement a solution that uses an Amazon S3 bucket for shared storage. Until the application is fully migrated and code is rewritten to use native Amazon S3 APIs, the application must continue to have access to the data through SMB. The solutions architect must migrate the application data to AWS to its new location, while still allowing the on-premises application to access the data. Which solution will meet these requirements? A. Create a new Amazon FSx for Windows File Server file system. Configure AWS DataSync with one location for the on-premises file share and one location for the new Amazon FSx file system. Create a new DataSync task to copy the data from the on-premises file share location to the Amazon FSx file system. B. Create an S3 bucket for the application. Copy the data from the on-premises storage to the S3 bucket. C. Deploy an AWS Server Migration Service, AWS SMS VM, to the on-premises environment. Use AWS SMS to migrate the file storage server from on-premises to an Amazon EC2 instance. D. Create an S3 bucket for the application. Deploy a new AWS Storage Gateway file gateway on an on-premises VM. Create a new file share that stores data in the S3 bucket and is associated with the file gateway. Copy the data from the on-premises storage to the new file gateway endpoint. A company has an application that has a web frontend. The application runs in the company's on-premises data center and requires access to file storage for critical data. The application runs on 3 Linux VMs for redundancy. The architecture includes a load balancer with HTTP request-based routing. The company needs to migrate the application to AWS as quickly as possible. The architecture on AWS must be highly available. Which solution will meet these requirements with the fewest changes to the architecture? A. Migrate the application to Amazon Elastic Container Service, Amazon ECS containers that use the Fargate launch type in 3 availability zones. Use Amazon S3 to provide file storage for all 3 containers. Use a network load balancer to direct traffic to the containers. B. Migrate the application to Amazon EC2 instances in 3 availability zones. Use Amazon Elastic File System, Amazon EFS, for file storage. Mount the file storage on all 3 EC2 instances. Use an application load balancer to direct traffic to the EC2 instances. C. Migrate the application to Amazon Elastic Kubernetes Service, Amazon EKS containers that use the Fargate launch type in 3 availability zones. Use Amazon FSx for Lustre to provide file storage for all 3 containers. Use a network load balancer to direct traffic to the containers. D. Migrate the application to Amazon EC2 instances in 3 AWS regions. Use Amazon Elastic Block Store, Amazon EBS, for file storage. Enable cross-region replication (CRR) for all 3 EC2 instances. Use an application load balancer to direct traffic to the EC2 instances. A company that develops consumer electronics with offices in Europe and Asia has 60 terabytes of software images stored on premises in Europe. The company wants to transfer the images to an Amazon S3 bucket in the AP Northeast 1 region. New software images are created daily and must be encrypted in transit. The company needs a solution that does not require custom development to automatically transfer all existing and new software images to Amazon S3. What is the next step in the transfer process? A. Deploy an AWS DataSync agent and configure a task to transfer the images to the S3 bucket. B. Configure Amazon Kinesis Data Firehose to transfer the images using S3 transfer acceleration. C. Use an AWS Snowball device to transfer the images with the S3 bucket as the target. D. Transfer the images over a site-to-site VPN connection using the S3 API with multi-part upload. A company creates an AWS Control Tower landing zone to manage and govern a multi-account AWS environment. The company's security team will deploy preventive controls and detective controls to monitor AWS services across all the accounts. The security team needs a centralized view of the security state of all the accounts. Which solution will meet these requirements? A. From the AWS Control Tower Management account, use AWS CloudFormation stack sets to deploy an AWS config conformance pack to all accounts in the organization. B. Enable Amazon Detective for the organization in AWS organizations. Designate one AWS account as the delegated administrator for Detective. C. From the AWS Control Tower Management account, deploy an AWS CloudFormation stack set that uses the automatic deployment option to enable Amazon Detective for the organization. D. Enable AWS Security Hub for the organization in AWS organizations. Designate one AWS account as the delegated administrator for Security Hub. A company has an application that stores data in a single Amazon S3 bucket. The company must keep all data for 1 year. The company's security team is concerned that an attacker could gain access to the AWS account through leaked long-term credentials. Which solution will ensure that existing and future objects in the S3 bucket are protected? A. Create a new AWS account that is accessible only to the security team through an assumed role. Create an S3 bucket in the new account. Enable S3 versioning and S3 object lock. Configure a default retention period of 1 year. Set up replication from the existing S3 bucket to the new S3 bucket. Create an S3 batch replication job to copy all existing data. B. Use the S3 bucket versioning enabled AWS config managed rule. Configure an automatic remediation action that uses an AWS Lambda function to enable S3 versioning and MFA delete on non-compliant resources. Add an S3 lifecycle rule to delete objects after 1 year. C. Explicitly deny bucket creation from all users and roles, except for an AWS Service Catalog launch constraint role. Define a Service Catalog product for the creation of the S3 bucket to force S3 versioning and MFA delete to be enabled. Authorize users to launch the product when they need to create an S3 bucket. D. Enable Amazon Guard Duty with the S3 protection feature for the account and the AWS region. Add an S3 lifecycle rule to delete objects after 1 year. A company runs a Python script on an Amazon EC2 instance to process data. The script runs every 10 minutes. The script ingests files from an Amazon S3 bucket and processes the files. On average, the script takes approximately 5 minutes to process each file. The script will not reprocess a file that the script has already processed. The company reviewed Amazon CloudWatch metrics and noticed that the EC2 instance is idle for approximately 40% of the time because of the file processing speed. The company wants to make the workload highly available and scalable. The company also wants to reduce long-term management overhead. Which solution will meet these requirements most cost-effectively? A. Migrate the data processing script to an AWS Lambda function. Use an S3 event notification to invoke the Lambda function to process the objects when the company uploads the objects. B. Create an Amazon Simple Queue service, Amazon SQSQ. Configure Amazon S3 to send event notifications to the SQSQ. Create an EC2 auto-scaling group with a minimum size of 1 instance. Update the data processing script to pull the SQSQ. Process the S3 objects that the SQS message identifies. C. Migrate the data processing script to a container image. Run the data processing container on an EC2. Configure the container to pull the S3 bucket for new objects and to process the resulting objects. D. Migrate the data processing script to a container image that runs on Amazon Elastic Container Service, Amazon ECS, on AWS Fargate. Create an AWS Lambda function that calls the Fargate Run Task API operation when the container processes the file. Use an S3 event notification to invoke the Lambda function. A company is planning a migration from an on-premises data center to the AWS cloud. The company plans to use multiple AWS accounts that are managed in an organization in AWS organizations. The company will create a small number of accounts initially and will add accounts as needed. A solutions architect must design a solution that turns on AWS CloudTrail in all AWS accounts. What is the most operationally efficient solution that meets these requirements? A. Create an AWS Lambda function that creates a new CloudTrail trail in all AWS accounts in the organization. Invoke the Lambda function daily by using a scheduled action in Amazon Event Bridge. B. Create a new CloudTrail trail in the organization's management account. Configure the trail to log all events for all AWS accounts in the organization. C. Create a new CloudTrail trail in all AWS accounts in the organization. Create new trails whenever a new account is created. Define an SCP that prevents deletion or modification of trails. Apply the SCP to the root OU. D. Create an AWS Systems Manager automation runbook that creates a CloudTrail trail in all AWS accounts in the organization. Invoke the automation by using Systems Manager State Manager. A company has AWS accounts that are in an organization in AWS organizations. The company wants to track Amazon EC2 usage as a metric. The company's architecture team must receive a daily alert if the EC2 usage is more than 10% higher the average EC2 usage from the last 30 days. Which solution will meet these requirements? A. Configure AWS budgets in the organization's management account. Specify a usage type of EC2 running hours. Specify a daily period. Set the budget amount to be 10% more than the reported average usage for the last 30 days from AWS Cost Explorer. Configure an alert to notify the architecture team if the usage threshold is met. B. Configure AWS Cost Anomaly Detection in the organization's management account. Configure a monitor type of AWS service. Apply a filter of Amazon EC2. Configure an alert subscription to notify the architecture team if the usage is 10% more than the average usage for the last 30 days. C. Enable AWS Trusted Advisor in the organization's management account. Configure a cost optimization advisory alert to notify the architecture team if the EC2 usage is 10% more than the reported average usage for the last 30 days. D. Configure Amazon Detective in the organization's management account. Configure an EC2 usage anomaly alert to notify the architecture team if Detective identifies a usage anomaly of more than 10%. A company uses an organization in AWS organizations to manage multiple AWS accounts. The company hosts some applications in a VPC in the company's shared services account. The company has attached a transit gateway to the VPC in the shared services account. The company is developing a new capability and has created a development environment that requires access to the applications that are in the shared services account. The company intends to delete and recreate resources frequently in the development account. The company also wants to give a development team the ability to recreate the team's connection to the shared services account as required. Which solution will meet these requirements? A. Create a transit gateway in the development account. Create a transit gateway peering request to the shared services account. Configure the shared services transit gateway to automatically accept peering connections. B. Turn on automatic acceptance for the transit gateway in the shared services account. Use AWS Resource Access Manager, AWS RAM, to share the transit gateway resource in the shared services account with the development account. Accept the resource in the development account. Create a transit gateway attachment in the development account. C. Turn on automatic acceptance for the transit gateway in the shared services account. Create a VPC endpoint. Use the endpoint policy to grant permissions on the VPC endpoint for the development account. Configure the endpoint service to automatically accept connection requests. Provide the endpoint details to the development team. D. Create an Amazon Event Bridge rule to invoke an AWS Lambda function that accepts the transit gateway attachment when the development account makes an attachment request. Use AWS Network Manager to share the transit gateway in the shared services account with the development account. Accept the transit gateway in the development account. A company uses AWS organizations to manage its AWS accounts. A solutions architect must design a solution in which only administrator roles are allowed to use IAM actions. However, the solutions architect does not have access to all the AWS accounts throughout the company. Which solution meets these requirements with the least operational overhead? A. Create an SCP that applies to all the AWS accounts to allow IAM actions only for administrator roles. Apply the SCP to the root OU. B. Configure AWS CloudTrail to invoke an AWS Lambda function for each event that is related to IAM actions. Configure the function to deny the action if the user who invoked the action is not an administrator. C. Create an SCP that applies to all the AWS accounts to deny IAM actions for all users, except for those with administrator roles. Apply the SCP to the root OU. D. Set an IAM permissions boundary that allows IAM actions. Attach the permissions boundary to every administrator role across all the AWS accounts. A company needs to implement disaster recovery for a critical application that runs in a single AWS region. The application's users interact with a web frontend that is hosted on Amazon EC2 instances behind an application load balancer, ALB. The application writes to an Amazon RDS from MySQL DB instance. The application also outputs processed documents that are stored in an Amazon S3 bucket. The company's finance team directly queries the database to run reports. During busy periods, these queries consume resources and negatively affect application performance. A solutions architect must design a solution that will provide resiliency during a disaster. The solution must minimize data loss and must resolve the performance problems that result from the finance team's queries. Which solution will meet these requirements? A company needs to monitor a growing number of Amazon S3 buckets across 2 AWS regions. The company also needs to track the percentage of objects that are encrypted in Amazon S3. The company needs a dashboard to display this information for internal compliance teams. Which solution will meet these requirements with the least operational overhead? A. Create a new 3-storage lens dashboard in each region to track bucket and encryption metrics. Aggregate data from both region dashboards into a single dashboard in Amazon QuickSight for the compliance team. B. Deploy an AWS Lambda function in each region to list the number of buckets and the encryption status of objects. Store this data in Amazon S3. Use Amazon Athena queries to display the data on a custom dashboard in Amazon QuickSight for the compliance teams. C. Use the S3 Storage Lens default dashboard to track bucket and encryption metrics. Give the compliance teams access to the dashboard directly in the S3 console. D. Create an Amazon Event Bridge rule to detect AWS CloudTrail events for S3 object creation. Configure the rule to invoke an AWS Lambda function to record encryption metrics in Amazon DynamoDB. Use Amazon QuickSight to display the metrics in a dashboard for the compliance teams. A company maintains information on premises in approximately 1 million .csv files that are hosted on a VM. The data initially is 10 terabytes in size and grows at a rate of 1 terabyte each week. The company needs to automate backups of the data to the AWS cloud. Backups of the data must occur daily. The company needs a solution that applies custom filters to back up only a subset of the data that is located in designated source directories. The company has set up an AWS Direct Connect connection. Which solution will meet the backup requirements with the least operational overhead? A. Use the Amazon S3 Copy Object API operation with multi-part upload to copy the existing data to Amazon S3. Use the Copy Object API operation to replicate new data to Amazon S3 daily. B. Create a backup plan in AWS Backup to back up the data to Amazon S3. Schedule the backup plan to run daily. C. Install the AWS DataSync agent as a VM that runs on the on-premises hypervisor. Configure a DataSync task to replicate the data to Amazon S3 daily. D. Use an AWS Snowball Edge device for the initial backup. Use AWS DataSync for incremental backups to Amazon S3 daily. A solutions architect has launched multiple Amazon EC2 instances in a placement group within a single availability zone. Because of additional load on the system, the solutions architect attempts to add new instances to the placement group. However, the solutions architect receives an insufficient capacity error. What should the solutions architect do to troubleshoot this issue? A. Use a spread placement group. Set a minimum of 8 instances for each availability zone. B. Stop and start all the instances in the placement group. Try the launch again. C. Create a new placement group. Merge the new placement group with the original placement group. D. Launch the additional instances as dedicated hosts in the placement groups. A solutions architect must provide a secure way for a team of cloud engineers to use the AWS CLI to upload objects into an Amazon S3 bucket. Each cloud engineer has an IAM user, IAM access keys, and a virtual multi-factor authentication (MFA) device. The IAM users for the cloud engineers are in a group that is named S3 Access. The cloud engineers must use MFA to perform any actions in Amazon S3. Which solution will meet these requirements? A. Attach a policy to the S3 bucket to prompt the IAM user for an MFA code when the IAM user performs actions on the S3 bucket. Use IAM access keys with the AWS CLI to call Amazon S3. B. Update the trust policy for the S3 access group to require principals to use MFA when principals assume the group. Use IAM access keys with the AWS CLI to call Amazon S3. C. Attach a policy to the S3 access group to deny all S3 actions unless MFA is present. Use IAM access keys with the AWS CLI to call Amazon S3. D. Attach a policy to the S3 access group to deny all S3 actions unless MFA is present. Request temporary credentials from AWS Security Token Service, AWS STS. Attach the temporary credentials in a profile that Amazon S3 will reference when the user performs actions in Amazon S3. A company needs to modernize an application and migrate the application to AWS. The application stores user profile data as text in a single table in an on-premises MySQL database. After the modernization, users will use the application to upload video files that are up to 4 GB in size. Other users must be able to download the video files from the application. The company needs a video storage solution that provides rapid scaling. The solution must not affect application performance. Which solution will meet these requirements? A. Migrate the database to Amazon Aurora PostgreSQL by using AWS Database Migration Service, AWS DMS. Store the videos as base 64 encoded strings in a txt column in the database. B. Migrate the database to Amazon DynamoDB by using AWS Database Migration Service, AWS DMS, with the AWS Schema Conversion Tool, AWS SCT. Store the videos as objects in Amazon S3. Store the S3 key in the corresponding DynamoDB item. C. Migrate the database to Amazon Keyspaces for Apache Cassandra by using AWS Database Migration Service, AWS DMS, with the AWS Schema Conversion Tool, AWS SCT. Store the videos as objects in Amazon S3. Store the S3 object identifier in the corresponding Amazon Keyspaces entry. A. Migrate the database to Amazon DynamoDB by using AWS Database Migration Service, AWS DMS, with the AWS Schema Conversion Tool, AWS SCT. Store the videos as base 64 encoded strings and the corresponding DynamoDB item. A solutions architect must implement a multi-region architecture for an Amazon RDS for PostgreSQL database that supports a web application. The database launches from an AWS CloudFormation template that includes AWS services and features that are present in both the primary and secondary regions. The database is configured for automated backups, and it has an RTO of 15 minutes and an RPO of 2 hours. The web application is configured to use an Amazon Route 53 record to route traffic to the database. Which combination of steps will result in a highly available architecture that meets all the requirements? Choose 2. A. Create a cross-region read replica of the database in the secondary region. Configure an AWS Lambda function in the secondary region to promote the read replica during a failover event. B. In the primary region, create a health check on the database that will invoke an AWS Lambda function when a failure is detected. Program the Lambda function to recreate the database from the latest database snapshot in the secondary region and update the Route 53 host records for the database. C. Create an AWS Lambda function to copy the latest automated backup to the secondary region every 2 hours. D. Create a failover routing policy in Route 53 for the database DNS record. Set the primary and secondary endpoints to the endpoints in each region. E. Create a hot standby database in the secondary region. Use an AWS Lambda function to restore the secondary database to the latest RDS automatic backup in the event that the primary database fails. A company is running a web crawling process on a list of target URLs to obtain training documents for machine learning training algorithms. A fleet of Amazon EC2 micro-instances pulls the target URLs from an Amazon Simple Queue service, Amazon SQSQ. The instances then write the result of the crawling algorithm as a.csv file to an Amazon Elastic File System, Amazon EFS volume. The EFS volume is mounted on all instances of the fleet. A separate system adds the URLs to the SQS queue at infrequent rates. The instances crawl each URL in 10 seconds or less. Metrics indicate that some instances are idle when no URLs are in the SQS queue. A solutions architect needs to redesign the architecture to optimize costs. Which combination of steps will meet these requirements most cost-effectively? Choose 2. A. Use M5.8 extra-large instances instead of T2. Micro-instances for the web crawling process. Reduce the number of instances in the fleet by 50%. B. Convert the web crawling process into an AWS Lambda function. Configure the Lambda function to pull URLs from the SQS queue. C. Modify the web crawling process to store results in Amazon Neptune. D. Modify the web crawling process to store results in an Amazon Aurora serverless MySQL instance. E. Modify the web crawling process to store results in Amazon S3. A company is running a containerized application in the AWS cloud. The application is running by using Amazon Elastic Container Service, Amazon ECS, on a set of Amazon EC2 instances. The EC2 instances run in an autoscaling group. The company uses Amazon Elastic Container Registry, Amazon ECR, to store its container images. When a new image version is uploaded, the new image version receives a unique tag. The company needs a solution that inspects new image versions for common vulnerabilities and exposures. The solution must automatically delete new image tags that have critical or high-severity findings. The solution also must notify the development team when such a deletion occurs. Which solution meets these requirements? An international delivery company hosts a delivery management system on AWS. Drivers use the system to upload confirmation of delivery. Confirmation includes the recipient's signature or a photo of the package with the recipient. The driver's handheld device uploads signatures and photos through FTP to a single Amazon EC2 instance. Each handheld device saves a file in a directory based on the signed-in user, and the file name matches the delivery number. The EC2 instance then adds metadata to the file after querying a central database to pull delivery information. The file is then placed in Amazon S3 for archiving. As the company expands, drivers report that the system is rejecting connections. The FTP server is having problems because of dropped connections and memory issues. In response to these problems, a system engineer schedules a cron task to reboot the EC2 instance every 30 minutes. The billing team reports that files are not always in the archive and that the central system is not always updated. A solutions architect needs to design a solution that maximizes scalability to ensure that the archive always receives the files and that systems are always updated. The handheld devices cannot be modified, so the company cannot deploy a new application. Which solution will meet these requirements? A company wants to migrate its website from an on-premises data center onto AWS. At the same time, it wants to migrate the website to a containerized microservice-based architecture to improve the availability and cost efficiency. The company's security policy states that privileges and network permissions must be configured according to best practice, using least privilege. A solutions architect must create a containerized architecture that meets the security requirements and has deployed the application to an Amazon ECS cluster. What steps are required after the deployment to meet the requirements? Choose 2. A. Create tasks using the bridge network mode. B. Create tasks using the AWS VPC network mode. C. Apply security groups to Amazon EC2 instances, and use IAM roles for EC2 instances to access other resources. D. Apply security groups to the tasks, and pass IAM credentials into the container at launch time to access other resources. E. Apply security groups to the tasks, and use IAM roles for tasks to access other resources. A company has an organization that has many AWS accounts in AWS organizations. A solutions architect must improve how the company manages common security group rules for the AWS accounts in the organization. The company has a common set of IPC-IDR ranges in an allow list in each AWS account to allow access to and from the company's on-premises network. Developers within each account are responsible for adding new IPC-IDR ranges to their security groups. The security team has its own AWS account. Currently, the security team notifies the owners of the other AWS accounts when changes are made to the allow list. The solutions architect must design a solution that distributes the common set of CIDR ranges across all accounts. Which solution meets these requirements with the least amount of operational overhead? A. Set up an Amazon Simple Notification Service, Amazon SNS topic, in the security team's AWS account. Deploy an AWS Lambda function in each AWS account. Configure the Lambda function to run every time an SNS topic receives a message. Configure the Lambda function to take an IP address as input and add it to a list of security groups in the account. Instruct the security team to distribute changes by publishing messages to its SNS topic. B. Create new customer-managed prefix lists in each AWS account within the organization. Populate the prefix lists in each account with all internal CIDR ranges. Notify the owner of each AWS account to allow the new customer-managed prefix list IDs in their accounts in their security groups. Instruct the security team to share updates with each AWS account owner. C. Create a new customer-managed prefix list in the security team's AWS account. Populate the customer-managed prefix list with all internal CIDR ranges. Share the customer-managed prefix list with the organization by using AWS Resource Access Manager. Notify the owner of each AWS account to allow the new customer-managed prefix list ID in their security groups. D. Create an IAM role in each account in the organization. Grant permissions to update security groups. Deploy an AWS Lambda function in the security team's AWS account. Configure the Lambda function to take a list of internal IP addresses as input, assume a role in each organization account, and add the list of IP addresses to the security groups in each account. A company provides a software as a service SaaS application that runs in the AWS cloud. The application runs on Amazon EC2 instances behind a network load balancer, NLB. The instances are in an auto-scaling group and are distributed across 3 availability zones in a single AWS region. The company is deploying the application into additional regions. The company must provide static IP addresses for the application to customers so that the customers can add the IP addresses to allow lists. The solution must automatically route customers to the region that is geographically closest to them. Which solution will meet these requirements? A. Create an Amazon CloudFront distribution. Create a CloudFront origin group. Add the NLB for each additional region to the origin group. Provide customers with the IP address ranges of the distribution's edge locations. B. Create an AWS Global Accelerator Standard Accelerator. Create a standard accelerator endpoint for the NLB in each additional region. Provide customers with the Global Accelerator IP address. C. Create an Amazon CloudFront distribution. Create a custom origin for the NLB in each additional region. Provide customers with the IP address ranges of the distribution's edge locations. D. Create an AWS Global Accelerator custom routing accelerator. Create a listener for the custom routing accelerator. Add the IP address and ports for the NLB in each additional region. Provide customers with the Global Accelerator IP address. A solutions architect needs to advise a company on how to migrate its on-premises data processing application to the AWS cloud. Currently, users upload input files through a web portal. The web server then stores the uploaded files on NAS and messages the processing server over a message queue. Each media file can take up to 1 hour to process. The company has determined that the number of media files awaiting processing is significantly higher during business hours, with the number of files rapidly declining after business hours. What is the most cost-effective migration recommendation? A. Create a queue using Amazon SQS. Configure the existing web server to publish to the new queue. When there are messages in the queue, invoke an AWS Lambda function to pull requests from the queue and process the files. Store the processed files in an Amazon S3 bucket. B. Create a queue using Amazon MQ. Configure the existing web server to publish to the new queue. When there are messages in the queue, create a new Amazon EC2 instance to pull requests from the queue and process the files. Store the processed files in Amazon EFS. Shut down the EC2 instance after the task is complete. C. Create a queue using Amazon MQ. Configure the existing web server to publish to the new queue. When there are messages in the queue, invoke an AWS Lambda function to pull requests from the queue and process the files. Store the processed files in Amazon EFS. D. Create a queue using Amazon SQS. Configure the existing web server to publish to the new queue. Use Amazon EC2 instances in an EC2 auto-scaling group to pull requests from the queue and process the files. Scale the EC2 instances based on the SQS queue length. Store the processed files in an Amazon S3 bucket. A retail company is operating its e-commerce application on AWS. The application runs on Amazon EC2 instances behind an application load balancer, ALB. The company uses an Amazon RDSDB instance as the database backend. Amazon CloudFront is configured with one origin that points to the ALB. Static content is cached. Amazon Route 53 is used to host all public zones. After an update of the application, the ALB occasionally returns a 502 status code, bad gateway error. The root cause is malformed HTTP headers that are returned to the ALB. The web page returns successfully when a solutions architect reloads the web page immediately after the error occurs. While the company is working on the problem, the solutions architect needs to provide a custom error page instead of the standard ALB error page to visitors. Which combination of steps will meet this requirement with the least amount of operational overhead? Choose 2. A. Create an Amazon S3 bucket. Configure the S3 bucket to host a static web page. Upload the custom error pages to Amazon S3. B. Create an Amazon CloudWatch alarm to invoke an AWS Lambda function if the ALB health check response target failed health checks is greater than 0. Configure the Lambda function to modify the forwarding rule at the ALB to point to a publicly accessible web server. C. Modify the existing Amazon Route 53 records by adding health checks. Configure a fallback target if the health check fails. Modify DNS records to point to a publicly accessible web page. B. Create an Amazon CloudWatch alarm to invoke an AWS Lambda function if the ALB Health Check Response (ELB) internal error is greater than 0. Configure the Lambda function to modify the forwarding rule at the ALB to point to a public accessible web server. Add a custom error response by configuring a CloudFront custom error page. Modify DNS records to point to a publicly accessible web page. A company is designing a new website that hosts static content. The website will give users the ability to upload and download large files. According to company requirements, all data must be encrypted in transit and at rest. A solutions architect is building the solution by using Amazon S3 and Amazon CloudFront. Which combination of steps will meet the encryption requirements? Choose 3. A. Turn on S3 server-side encryption for the S3 bucket that the web application uses. B. Add a policy attribute of AWS, secure transport, true, for read and write operations in the S3 ACLs. C. Create a bucket policy that denies any unencrypted operations in the S3 bucket that the web application uses. D. Configure encryption at rest on CloudFront by using server-side encryption with AWS KMS keys, SSEKMS. E. Configure redirection of HTTP requests to HTTPS requests in CloudFront. F. Use the Require SSL option in the creation of presigned URLs for the S3 bucket that the web application uses. A company hosts a web application on AWS in the US East 1 region. The application servers are distributed across 3 availability zones behind an application load balancer. The database is hosted in a MySQL database on an Amazon EC2 instance. A solutions architect needs to design a cross-region data recovery solution using AWS services with an RTO of less than 5 minutes and an RPO of less than 1 minute. The solutions architect is deploying application servers in US West 2 and has configured Amazon Route 53 health checks and DNS failover to US West 2. Which additional step should the solutions architect take? A. Migrate the database to an Amazon RDS for MySQL instance with a cross-region read replica in US West 2. B. Migrate the database to an Amazon Aurora global database with the primary in US East 1 and the secondary in US West 2. C. Migrate the database to an Amazon RDS for MySQL instance with a multi-AZ deployment. D. Create a MySQL standby database on an Amazon EC2 instance in US West 2. A company is running a critical application that uses an Amazon RDS for MySQL database to store data. The RDS-DB instance is deployed in multi-AZ mode. A recent RDS database failover test caused a 40-second outage to the application. A solutions architect needs to design a solution to reduce the outage time to less than 20 seconds. Which combination of steps should the solutions architect take to meet these requirements? Choose 3. A. Use Amazon ElastiCache for memcached in front of the database. B. Use Amazon ElastiCache for Redis in front of the database. C. Use RDS proxy in front of the database. D. Migrate the database to Amazon Aurora MySQL. E. Create an Amazon Aurora replica. F. Create an RDS for MySQL read replica. A publishing company's design team updates the icons and other static assets that an e-commerce web application uses. The company serves the icons and assets from an Amazon S3 bucket that is hosted in the company's production account. The company also uses a development account that members of the design team can access. After the design team tests the static assets in the development account, the design team needs to load the assets into the S3 bucket in the production account. A solutions architect must provide the design team with access to the production account without exposing other parts of the web application to the risk of unwanted changes. Which combination of steps will meet these requirements? Choose 3. A. In the production account, create a new IAM policy that allows read and write access to the S3 bucket. B. In the development account, create a new IAM policy that allows read and write access to the S3 bucket. C. In the production account, create a role, attach the new policy to the role. Define the development account as a trusted entity. D. In the development account, create a role, attach the new policy to the role. Define the production account as a trusted entity. A. In the development account, create a group that contains all the IAM users of the design team. Attach a different IAM policy to the group to allow the STS. Assume role action on the role in the production account. F. In the development account, create a group that contains all the IAM users of the design team. Attach a different IAM policy to the group to allow the STS. Assume role action on the role in the development account. A company is running a web application in the AWS cloud. The application consists of dynamic content that is created on a set of Amazon EC2 instances. The EC2 instances run in an auto-scaling group that is configured as a target group for an application load balancer, ALB. The company is using an Amazon CloudFront distribution to distribute the application globally. The CloudFront distribution uses the ALB as an origin. The company uses Amazon Route 53 for DNS and has created an A record of www.example.com for the CloudFront distribution. A solutions architect must configure the application so that it is highly available and fault-tolerant. Which solution meets these requirements? A. Provision a full, secondary application deployment in a different AWS region. Update the Route 53A record to be a failover record. Add both of the CloudFront distributions as values. Create Route 53 health checks. B. Provision an ALB, an auto-scaling group, and EC2 instances in a different AWS region. Update the CloudFront distribution and create a second origin for the new AL. Create an origin group for the two origins. Configure one origin as primary and one origin as secondary. C. Provision an autoscaling group and EC2 instances in a different AWS region. Create a second target for the new autoscaling group in the ALB. Set up the failover routing algorithm on the ALB. D. Provision a full secondary application deployment in a different AWS region. Create a second CloudFront distribution and add the new application setup as an origin. Create an AWS Global Accelerator. Add both of the CloudFront distributions as endpoints. A company wants to migrate an Amazon Aurora MySQL cluster from an existing AWS account to a new AWS account in the same AWS region. Both accounts are members of the same organization in AWS organizations. The company must minimize database service interruption before the company performs DNS cutover to the new database. Which migration strategy will meet this requirement? Choose 2. A. Take a snapshot of the existing Aurora database. Share the snapshot with the new AWS account. Create an Aurora DB cluster in the new account from the snapshot. B. Create an Aurora DB cluster in the new AWS account. Use AWS Database Migration Service, AWS DMS, to migrate data between the two Aurora DB clusters. C. Use AWS Backup to share an Aurora database backup from the existing AWS account to the new AWS account. Create an Aurora DB cluster in the new AWS account from the snapshot. D. Create an Aurora DB cluster in the new AWS account. Use AWS Application Migration Service to migrate data between the two Aurora DB clusters. A company is migrating an application to the AWS cloud. The application runs in an on-premises data center and writes thousands of images into a mounted NFS file system each night. After the company migrates the application, the company will host the application on an Amazon EC2 instance with a mounted Amazon Elastic file system, Amazon EFS file system. The company has established an AWS Direct connection to AWS. Before the migration cutover, a solutions architect must build a process that will replicate the newly created on-premises images to the EFS file system. What is the most operationally efficient way to replicate the images? A. Configure a periodic process to run the AWS S3 sync command from the on-premises file system to Amazon S3. Configure an AWS Lambda function to process event notifications from Amazon S3 and copy the images from Amazon S3 to the EFS file system. B. Deploy an AWS Storage Gateway file gateway with an NFS mount point. Mount the file gateway file system on the on-premises server. Configure a process to periodically copy the images to the mount point. C. Deploy an AWS DataSync agent to an on-premises server that has access to the NFS file system. Send data over the Direct Connect connection to an S3 bucket by using a public VIF. Configure an AWS Lambda function to process event notifications from Amazon S3 and copy the images from Amazon S3 to the EFS file system. D. Deploy an AWS DataSync agent to an on-premises server that has access to the NFS file system. Send data over the Direct Connect connection to an AWS Private Link Interface VPC endpoint for Amazon EFS by using a private VIF. Configure a DataSync scheduled task to send the images to the EFS file system every 24 hours. A company has mounted sensors to collect information about environmental parameters such as humidity and light throughout all the company's factories. The company needs to stream and analyze the data in the AWS cloud in real time. If any of the parameters fall out of acceptable ranges, the factory operations team must receive a notification immediately. Which solution will meet these requirements? A. Stream the data to an Amazon Kinesis Data Firehose delivery stream. Use AWS step functions to consume and analyze the data in the Kinesis Data Firehose delivery stream. Use Amazon Simple Notification Service, Amazon SNS, to notify the operations team. B. Stream the data to an Amazon Managed Streaming for Apache Kafka, Amazon MSK cluster. Set up a trigger in Amazon MSK to invoke an AWS Fargate task to analyze the data. Use Amazon Simple Email Service, Amazon SES, to notify the operations team. C. Stream the data to an Amazon Kinesis data stream. Create an AWS Lambda function to consume the Kinesis data stream and to analyze the data. Use Amazon Simple Notification Service, Amazon SNS, to notify the operations team. D. Stream the data to an Amazon Kinesis data analytics application. Use an automatically scaled and containerized service in Amazon Elastic Container Service, Amazon ECS, to consume and analyze the data. Use Amazon's simple email service, Amazon SES, to notify the operations team. A retail company wants to improve its application architecture. The company's applications register new orders, handle returns of merchandise, and provide analytics. The applications store retail data in a MySQL database and an Oracle OLAP Analytics database. All the applications and databases are hosted on Amazon EC2 instances. Each application consists of several components that handle different parts of the order process. These components use incoming data from different sources. A separate ETL job runs every week and copies data from each application to the analytics database. A solutions architect must redesign the architecture into an event-driven solution that uses serverless services. The solution must provide updated analytics in near real time. Which solution will meet these requirements? A company is running a serverless application that consists of several AWS Lambda functions and Amazon DynamoDB tables. The company has created new functionality that requires the Lambda functions to access an Amazon Neptune DB cluster. The Neptune DB cluster is located in 3 subnets in a VPC. Which of the possible solutions will allow the Lambda functions to access the Neptune DB cluster and DynamoDB tables? Choose 2. A. Create 3 public subnets in the Neptune VPC and route traffic through an internet gateway. Host the Lambda functions in the 3 new public subnets. B. Create 3 private subnets in the Neptune VPC and route internet traffic through a NAT gateway. Host the Lambda functions in the 3 new private subnets. C. Host the Lambda functions outside the VP. Update the Neptune security group to allow access from the IP ranges of the Lambda functions. D. Host the Lambda functions outside the VPC. Create a VPC endpoint for the Neptune database and have the Lambda functions access Neptune over the VPC endpoint. E. Create 3 private subnets in the Neptune VPC. Host the Lambda functions in the 3 new isolated subnets. Create a VPC endpoint for DynamoDB and route DynamoDB traffic to the VPC endpoint. A company owns a chain of travel agencies and is running an application in the AWS cloud. Company employees use the application to search for information about travel destinations. Destination content is updated 4 times each year. 2 fixed Amazon EC2 instances serve the application. The company uses an Amazon Route 53 public hosted zone with a multi-value record of travel.example.com that returns the elastic IP addresses for the EC2 instances. The application uses Amazon DynamoDB as its primary data store. The company uses a self-hosted Redis instance as a caching solution. During content updates, the load on the EC2 instances and the caching solution increases drastically. This increased load has led to downtime on several occasions. A solutions architect must update the application so that the application is highly available and can handle the load that is generated by the content updates. Which solution will meet these requirements? A financial services company sells its software as a service, SaaS, platform for application compliance to large global banks. The SaaS platform runs on AWS and uses multiple AWS accounts that are managed in an organization in AWS organizations. The SaaS platform uses many AWS resources globally. For regulatory compliance, all API calls to AWS resources must be audited, tracked for changes, and stored in a durable and secure data store. Which solution will meet these requirements with the least operational overhead? A. Create a new AWS CloudTrail. Use an existing Amazon S3 bucket in the organization's management account to store the logs. Deploy the trail to all AWS regions. Enable MFA delete and encryption on the S3 bucket. B. Create a new AWS CloudTrail trail in each member account of the organization. Create new Amazon S3 buckets to store the logs. Deploy the trail to all AWS regions. Enable MFA delete and encryption on the S3 buckets. C. Create a new AWS CloudTrail trail in the organization's management account. Create a new Amazon S3 bucket with versioning turned on to store the logs. Deploy the trail for all accounts in the organization. Enable MFA delete and encryption on the S3 bucket. D. Create a new AWS CloudTrail trail in the organization's management account. Create a new Amazon S3 bucket to store the logs. Configure Amazon's simple notification service, Amazon SNS, to send log file delivery notifications to an external management system that will track the logs. Enable MFA delete and encryption on the S3 bucket. An online magazine will launch its latest edition this month. This edition will be the first to be distributed globally. The magazine's dynamic website currently uses an application load balancer in front of the web tier, a fleet of Amazon EC2 instances for web and application servers, and Amazon Aurora MySQL. Portions of the website include static content, and almost all traffic is read-only. The magazine is expecting a significant spike in internet traffic when the new edition is launched. Optimal performance is a top priority for the week following the launch. Which combination of steps should a solutions architect take to reduce system response times for a global audience? Choose 2. A. Use logical cross-region replication to replicate the Aurora MySQL database to a secondary region. Replace the web servers with Amazon S3. Deploy S3 buckets in cross-region replication mode. B. Ensure the web and application tiers are each in auto-scaling groups. Introduce an AWS Direct Connect connection. Deploy the web and application tiers in regions across the world. C. Migrate the database from Amazon Aurora to Amazon RDS for MySQL. Ensure all three of the application tiers, web, application, and database, are in private subnets. D. Use an Aurora global database for physical cross-region replication. Use Amazon S3 with cross-region replication for static content and resources. Deploy the web and application tiers in regions across the world. E. Introduce Amazon Route 53 with latency-based routing and Amazon CloudFront distributions. Ensure the web and application tiers are each in auto-scaling groups. A financial services company loaded millions of historical stock trades into an Amazon DynamoDB table. The table uses on-demand capacity mode. Once each day at midnight, a few million new records are loaded into the table. Application read activity against the table happens in bursts throughout the day, and a limited set of keys are repeatedly looked up. The company needs to reduce costs associated with DynamoDB. Which strategy should a solutions architect recommend to meet this requirement? A. Deploy an Amazon Elasticache cluster in front of the DynamoDB table. B. Deploy DynamoDB Accelerator, DAX. Configure DynamoDB autoscaling. Purchase savings plans in Cost Explorer. C. Use provisioned capacity mode. Purchase savings plans in Cost Explorer. D. Deploy DynamoDB Accelerator, DAX. Use provisioned capacity mode. Configure DynamoDB autoscaling. A company has millions of objects in an Amazon S3 bucket. The objects are in the S3 standard storage class. All the S3 objects are accessed frequently. The number of users and applications that access the objects is increasing rapidly. The objects are encrypted with server-side encryption with AWS KMS keys, SSEKMS. A solutions architect reviews the company's monthly AWS invoice and notices that AWS KMS costs are increasing because of the high number of requests from Amazon S3. The solutions architect needs to optimize costs with minimal changes to the application. Which solution will meet these requirements with the least operational overhead? A. Create a new S3 bucket that has server-side encryption with customer-provided keys, SSEC, as the encryption type. Copy the existing objects to the new S3 bucket. Specify SSEC. B. Create a new S3 bucket that has server-side encryption with Amazon S3 managed keys, SSES3, as the encryption type. Use S3 batch operations to copy the existing objects to the new S3 bucket. Specify SSES3. C. Use AWS Cloud HSM to store the encryption keys. Create a new S3 bucket. Use S3 batch operations to copy the existing objects to the new S3 bucket. Encrypt the objects by using the keys from Cloud HSM. D. Use the S3 Intelligent Tiering Storage class for the S3 bucket. Create an S3 Intelligent Tiering Archive configuration to transition objects that are not accessed for 90 days to S3 Glacier Deep Archive. A large company recently experienced an unexpected increase in Amazon RDS and Amazon DynamoDB costs. The company needs to increase visibility into details of AWS billing and cost management. There are various accounts associated with AWS organizations, including many development and production accounts. There is no consistent tagging strategy across the organization, but there are guidelines in place that require all infrastructure to be deployed using AWS CloudFormation with consistent tagging. Management requires cost center numbers and project ID numbers for all existing and future DynamoDB tables and RDS instances. Which strategy should the solutions architect provide to meet these requirements? A. Use Tag Editor to tag existing resources. Create cost allocation tags to define the cost center and project ID, and allow 24 hours for tags to propagate to existing resources. B. Use an AWS config rule to alert the finance team of untagged resources. Create a centralized AWS Lambda-based solution to tag untagged RDS databases and DynamoDB resources every hour using a cross-account role. C. Use Tag Editor to tag existing resources. Create cost allocation tags to define the cost center and project ID. Use SCPs to restrict resource creation that do not have the cost center and project ID on the resource. D. Create cost allocation tags to define the cost center and project ID and allow 24 hours for tags to propagate to existing resources. Update existing federated roles to restrict privileges to provision resources that do not include the cost center and project ID on the resource. A company is collecting a large amount of data from a fleet of IoT devices. The data is stored as optimized row columnar (ORC) files in the Hadoop Distributed File System (HDFS) on a persistent Amazon EMR cluster. The company's data analytics team queries the data by using SQL in Apache Presto deployed on the same EMR cluster. Queries scan large amounts of data, always run for less than 15 minutes, and run only between 5 p.m. and 10 p.m. The company is concerned about the high cost associated with the current solution. A solutions architect must propose the most cost-effective solution that will allow SQL data queries. Which solution will meet these requirements? A. Store data in Amazon S3. Use Amazon Redshift Spectrum to query data. B. Store data in Amazon S3. Use the AWS Glue Data Catalog and Amazon Athena to query data. C. Store data in EMR file system, EMRFS. Use Presto in Amazon EMR to query data. D. Store data in Amazon Redshift. Use Amazon Redshift to query data. A company is planning to migrate an Amazon RDS for Oracle database to an RDS for PostgreSQL DB instance in another AWS account. A solutions architect needs to design a migration strategy that will require no downtime and that will minimize the amount of time necessary to complete the migration. The migration strategy must replicate all existing data and any new data that is created during the migration. The target database must be identical to the source database at completion of the migration process. All applications currently use an Amazon Route 53 CNAME record as their endpoint for communication with the RDS for Oracle DB instance. The RDS for Oracle DB instance is in a private subnet. Which combination of steps should the solutions architect take to meet these requirements? Choose 3. A. Create a new RDS for PostgreSQL DB instance in the target account. Use the AWS Schema Conversion Tool, AWS SCT, to migrate the database schema from the source database to the target database. B. Use the AWS Schema Conversion Tool, AWS SCT, to create a new RDS for PostgreSQL DB instance in the target account with the schema and initial data from the source database. C. Configure VPC peering between the VPCs in the two AWS accounts to provide connectivity to both DB instances from the target account. Configure the security groups that are attached to each DB instance to allow traffic on the database port from the VPC in the target account. A. Temporarily allow the source DB instance to be publicly accessible to provide connectivity from the VPC in the target account. Configure the security groups that are attached to each DB instance to allow traffic on the database port from the VPC in the target account. E. Use AWS Database Migration Service, AWS DMS, in the target account to perform a full load plus change data capture, CDC, migration from the source database to the target database. When the migration is complete, change the CNAME record to point to the target DB instance endpoint. F. Use AWS Database Migration Service, AWS DMS, in the target account to perform a change data capture, CDC, migration from the source database to the target database. When the migration is complete, change the CNAME record to point to the target DB instance endpoint. A company has multiple business units that each have separate accounts on AWS. Each business unit manages its own network with several VPCs that have CIDR ranges that overlap. The company's marketing team has created a new internal application and wants to make the application accessible to all the other business units. The solution must use private IP addresses only. Which solution will meet these requirements with the least operational overhead? A. Instruct each business unit to add a unique secondary CIDR range to the business unit's VPC. Peer the VPCs and use a private NAT gateway in the secondary range to route traffic to the marketing team. B. Create an Amazon EC2 instance to serve as a virtual appliance in the marketing account's VPC. Create an AWS site-to-site VPN connection between the marketing team and each business unit's VPC. Perform NET where necessary. C. Create an AWS private link endpoint service to share the marketing application. Grant permission to specific AWS accounts to connect to the service. Create interface VPC endpoints in other accounts to access the application by using private IP addresses. D. Create a network load balancer (NLB) in front of the marketing application in a private subnet. Create an API Gateway API. Use the Amazon API Gateway private integration to connect the API to the NLB. Activate IAM authorization for the API. Grant access to the accounts of the other business units. A company is running an application that uses an Amazon ElastiCache for Redis cluster as a caching layer. A recent security audit revealed that the company has configured encryption at rest for ElastiCache. However, the company did not configure ElastiCache to use encryption in transit. Additionally, users can access the cache without authentication. A solutions architect must make changes to require user authentication and to ensure that the company is using end-to-end encryption. Which solution will meet these requirements? A. Create an AUth token. Store the token in AWS System Manager Parameter Store as an encrypted parameter. Create a new cluster with AUth and configure encryption in transit. Update the application to retrieve the AUth token from Parameter Store when necessary, and to use the AUth token for authentication. B. Create an AUth token. Store the token in AWS Secrets Manager. Configure the existing cluster to use the AUth token, and configure encryption in transit. Update the application to retrieve the AUth token from Secrets Manager when necessary, and to use the AUth token for authentication. C. Create an SSL certificate. Store the certificate in AWS Secrets Manager. Create a new cluster and configure encryption in transit. Update the application to retrieve the SSL certificate from Secrets Manager when necessary, and to use the certificate for authentication. D. Create an SSL certificate. Store the certificate in AWS Systems Manager Parameter Store as an encrypted advanced parameter. Update the existing cluster to configure encryption in transit. Update the application to retrieve the SSL certificate from Parameter Store when necessary, and to use the certificate for authentication. A company consists of two separate business units. Each business unit has its own AWS account within a single organization in AWS organizations. The business units regularly share sensitive documents with each other. To facilitate sharing, the company created an Amazon S3 bucket in each account and configured low-way replication between the S3 buckets. The S3 buckets have millions of objects. Recently, a security audit identified that neither S3 bucket has encryption at rest enabled. Company policy requires that all documents must be stored with encryption at rest. The company wants to implement server-side encryption with Amazon S3 Managed Encryption Keys, SSE S3. What is the most operationally efficient solution that meets these requirements? A. Turn on SSE S3 on both S3 buckets. Use S3 batch operations to copy and encrypt the objects in the same location. B. Create an AWS Key Management Service, AWS KMS, key in each account. Turn on server-side encryption with AWS KMS keys, SSE-KMS, on each S3 bucket by using the corresponding KMS key in that AWS account. Encrypt the existing objects by using an S3 copy command in the AWS CLI. C. Turn on SSE S3 on both S3 buckets. Encrypt the existing objects by using an S3 copy command in the AWS CLI. D. Create an AWS Key Management Service, AWS KMS key in each account. Turn on server-side encryption with AWS KMS keys, SSEKMS, on each S3 bucket by using the corresponding KMS key in that AWS account. Use S3 batch operations to copy the objects into the same location. A life sciences company is using a combination of open-source tools to manage data analysis workflows and Docker containers running on servers in its on-premises data center to process genomics data. Sequencing data is generated and stored on a local storage area network, SAN, and then the data is processed. The research and development teams are running into capacity issues and have decided to re-architect their genomics analysis platform on AWS to scale based on workload demands and reduce the turnaround time from weeks to days. The company has a high-speed AWS Direct Connect connection. Sequencers will generate around 200 gigabytes of data for each genome, and individual jobs can take several hours to process the data with ideal compute capacity. The end result will be stored in Amazon S3. The company is expecting 10 to 15 job requests each day. Which solution meets these requirements? A. Use regularly scheduled AWS Snowball Edge devices to transfer the sequencing data into AWS. When AWS receives the Snowball Edge device and the data is loaded into Amazon S3, use S3 events to trigger an AWS Lambda function to process the data. B. Use AWS Data Pipeline to transfer the sequencing data to Amazon S3. Use S3 events to trigger an Amazon EC2 auto-scaling group to launch custom AMI EC2 instances running the Docker containers to process the data. C. Use AWS DataSync to transfer the sequencing data to Amazon S3. Use S3 events to trigger an AWS Lambda function that starts an AWS Step Functions workflow. Store the Docker images in Amazon Elastic Container Registry, Amazon ECR, and trigger AWS Batch to run the container and process the sequencing data. D. Use an AWS Storage Gateway File Gateway to transfer the sequencing data to Amazon S3. Use S3 events to trigger an AWS batch job that executes on Amazon EC2 instances running the Docker containers to process the data. A solutions architect at a large company needs to set up network security for outbound traffic to the internet from all AWS accounts within an organization in AWS organizations. The organization has more than 100 AWS accounts, and the accounts route to each other by using a centralized AWS transit gateway. Each account has both an internet gateway and a NAT gateway for outbound traffic to the internet. The company deploys resources only into a single AWS region. The company needs the ability to add centrally managed rule-based filtering on all outbound traffic to the internet for all AWS accounts in the organization. The peak load of outbound traffic will not exceed 25 gigabits per second in each availability zone. Which solution meets these requirements? A. Create a new VPC for outbound traffic to the internet. Connect the existing transit gateway to the new VPC. Configure a new NAT gateway. Create an auto-scaling group of Amazon EC2 instances that run an open-source internet proxy for rule-based filtering across all availability zones in the region. Modify all default routes to point to the proxy's auto-scaling group. B. Create a new VPC for outbound traffic to the internet. Connect the existing transit gateway to the new VPC. Configure a new NAT gateway. Use an AWS network firewall for rule-based filtering. Create network firewall endpoints in each availability zone. Modify all default routes to point to the network firewall endpoints. C. Create an AWS network firewall for rule-based filtering in each AWS account. Modify all default routes to point to the network firewalls in each account. A. In each AWS account, create an auto-scaling group of network-optimized Amazon EC2 instances that run an open-source internet proxy for rule-based filtering. Modify all default routes to point to the proxy's auto-scaling group. A company has an on-premises website application that provides real estate information for potential renters and buyers. The website uses a Java backend and a NoSQL MongoDB database to store subscriber data. The company needs to migrate the entire application to AWS with a similar structure. The application must be deployed for high availability, and the company cannot make changes to the application. Which solution will meet these requirements? A. Use an Amazon Aurora DB cluster as the database for the subscriber data. Deploy Amazon EC2 instances in an auto-scaling group across multiple availability zones for the Java backend application. B. Use MongoDB on Amazon EC2 instances as the database for the subscriber data. Deploy EC2 instances in an auto-scaling group in a single availability zone for the Java backend application. C. Configure Amazon Document DB with MongoDB compatibility, with appropriately sized instances in multiple availability zones as the database for the subscriber data. Deploy Amazon EC2 instances in an auto-scaling group across multiple availability zones for the Java backend application. D. Configure Amazon Document DB with MongoDB compatibility in on-demand capacity mode in multiple availability zones as the database for the subscriber data. Deploy Amazon EC2 instances in an auto-scaling group across multiple availability zones for the Java backend application. A company has purchased appliances from different vendors. The appliances all have IoT sensors. The sensors send status information in the vendor's proprietary formats to a legacy application that parses the information into JSON. The parsing is simple, but each vendor has a unique format. Once daily, the application parses all the JSON records and stores the records in a relational database for analysis. The company needs to design a new data analysis solution that can deliver faster and optimize costs. Which solution will meet these requirements? A. Connect the IoT sensors to AWS IoT Core. Set a rule to invoke an AWS Lambda function to parse the information and save a.csv file to Amazon. S3. Use AWS Glue to catalog the files. Use Amazon Athena and Amazon QuickSight for analysis. B. Migrate the application server to AWS Fargate, which will receive the information from IoT sensors and parse the information into a relational format. Save the parsed information to Amazon Redshift for analysis. C. Create an AWS transfer for SFTP server. Update the IoT sensor code to send the information as a.csv file through SFTP to the server. Use AWS Glue to catalog the files. Use Amazon Athena for analysis. A. Use AWS Snowball Edge to collect data from the IoT sensors directly to perform local analysis. Periodically collect the data into Amazon Redshift to perform global analysis. A company is developing and hosting several projects in the AWS cloud. The projects are developed across multiple AWS accounts under the same organization in AWS organizations. The company requires the cost for cloud infrastructure to be allocated to the owning project. The team responsible for all of the AWS accounts has discovered that several Amazon EC2 instances are lacking the project tag used for cost allocation. Which actions should a solutions architect take to resolve the problem and prevent it from happening in the future? Choose 3. A. Create an AWS config rule in each account to find resources with missing tags. B. Create an SCP in the organization with a deny action for EC2. Run instances if the project tag is missing. C. Use Amazon Inspector in the organization to find resources with missing tags. D. Create an IAM policy in each account with a deny action for EC2. Run instances if the project tag is missing. E. Create an AWS config aggregator for the organization to collect a list of EC2 instances with the missing project tag. F. Use AWS Security Hub to aggregate a list of EC2 instances with the missing project tag. A large company is running a popular web application. The application runs on several Amazon EC2 Linux instances in an auto-scaling group in a private subnet. An application load balancer is targeting the instances in the auto-scaling group in the private subnet. AWS Systems Manager's Session Manager is configured. An AWS Systems Manager agent is running on all the EC2 instances. The company recently released a new version of the application. Some EC2 instances are now being marked as unhealthy and are being terminated. As a result, the application is running at reduced capacity. A solutions architect tries to determine the root cause by analyzing Amazon CloudWatch logs that are collected from the application, but the logs are inconclusive. How should the solutions architect gain access to an EC2 instance to troubleshoot the issue? A. Suspend the auto-scaling group's health check scaling process. Use Session Manager to log in to an instance that is marked as unhealthy. B. Enable EC2 instance termination protection. Use Session Manager to log in to an instance that is marked as unhealthy. C. Set the termination policy to oldest instance on the auto-scaling group. Use Session Manager to log in to an instance that is marked as unhealthy. D. Suspend the auto-scaling group's terminate process. Use Session Manager to log in to an instance that is marked as unhealthy. A company has an asynchronous HTTP application that is hosted as an AWS Lambda function. A public Amazon API gateway endpoint invokes the Lambda function. The Lambda function and the API gateway endpoint reside in the US East 1 region. A solutions architect needs to redesign the application to support failover to another AWS region. Which solution will meet these requirements? A. Create an API gateway endpoint in the US West 2 region to direct traffic to the Lambda function in US East 1. Configure Amazon Route 53 to use a failover routing policy to route traffic for the two API gateway endpoints. B. Create an Amazon Simple Queue service, Amazon SQSQ. Configure API gateway to direct traffic to the SQSQ instead of to the Lambda function. Configure the Lambda function to pull messages from the queue for processing. C. Deploy the Lambda function to the US West 2 region. Create an API gateway endpoint in US West 210 direct traffic to the Lambda function in US West 2. Configure AWS Global Accelerator and an application load balancer to manage traffic across the two API gateway endpoints. D. Deploy the Lambda function and an API gateway endpoint to the US West 2 region. Configure Amazon Route 53 to use a failover routing policy to route traffic for the two API gateway endpoints. A company runs a Java application that has complex dependencies on VMs that are in the company's data center. The application is stable, but the company wants to modernize the technology stack. The company wants to migrate the application to AWS and minimize the administrative overhead to maintain the servers. Which solution will meet these requirements with the least code changes? A. Migrate the application to Amazon Elastic Container Service, Amazon ECS, on AWS Fargate by using AWS SAP-C02 container. Store container images in Amazon Elastic Container Registry, Amazon ECR. Grant the ECS task execution role permission 10. Access the ECR image repository. Configure Amazon ECS to use an application load balancer, ALB. Use the ALB to interact with the application. B. Migrate the application code to a container that runs in AWS Lambda. Build an Amazon API Gateway REST API with Lambda integration. Use API Gateway to interact with the application. C. Migrate the application to Amazon Elastic Kubernetes Service, Amazon EKS, on EKS managed node groups by using AWS SAP-C02 container. Store container images in Amazon Elastic Container Registry, Amazon ECR. Give the EKS nodes permission to access the ECR image repository. Use Amazon API Gateway to interact with the application. D. Migrate the application code to a container that runs in AWS Lambda. Configure Lambda to use an application load balancer, ALB. Use the ALB to interact with the application. A finance company is running its business-critical application on current-generation Linux EC2 instances. The application includes a self-managed MySQL database performing heavy I/O operations. The application is working fine to handle a moderate amount of traffic during the month. However, it slows down during the final 3 days of each month due to month-end reporting. Even though the company is using elastic load balancers and auto-scaling within its infrastructure to meet the increased demand. Which of the following actions would allow the database to handle the month-end load with the least impact on performance? A. Pre-warming elastic load balancers, using a bigger instance type, changing all Amazon EBS volumes to GP2 volumes. B. Performing a one-time migration of the database cluster to Amazon RDS, and creating several additional read replicas to handle the load during end of month. C. Using Amazon CloudWatch with AWS Lambda to change the type, size, or IOPS of Amazon EBS volumes in the cluster based on a specific CloudWatch metric. D. Replacing all existing Amazon EBS volumes with new PIOPS volumes that have the maximum available storage size and I/O per second by taking snapshots before the end of the month and reverting back afterwards. A company has developed a web application. The company is hosting the application on a group of Amazon EC2 instances behind an application load balancer. The company wants to improve the security posture of the application and plans to use AWS WAF Web ACLs. The solution must not adversely affect legitimate traffic to the application. How should a solutions architect configure the Web ACLs to meet these requirements? A. Set the action of the Web ACL rules to count. Enable AWS WAF logging. Analyze the requests for false positives. Modify the rules to avoid any false positive. Over time, change the action of the Web ACL rules from count to block. B. Use only rate-based rules in the Web ACLs and set the throttle limit as high as possible. Temporarily block all requests that exceed the limit. Define nested rules to narrow the scope of the rate tracking. C. Set the action of the Web ACL rules to block. Use only AWS managed rule groups in the web ACLs. Evaluate the rule groups by using Amazon CloudWatch metrics with AWS WAF sampled requests or AWS WAF logs. D. Use only custom rule groups in the web ACLs and set the action to allow. Enable AWS WAF logging. Analyze the requests for false positives. Modify the rules to avoid any false positive. Over time, change the action of the web ACL rules from allow to block. A company is refactoring its on-premises order processing platform in the AWS cloud. The platform includes a web front-end that is hosted on a fleet of VMs, RabbitMQ to connect the front-end to the back-end, and a Kubernetes cluster to run a containerized back-end system to process the orders. The company does not want to make any major changes to the application. Which solution will meet these requirements with the least operational overhead? A. Create an AMI of the web server VM. Create an Amazon EC2 auto-scaling group that uses the AMI and an application load balancer. Set up Amazon MQ to replace the on-premises messaging queue. Configure Amazon Elastic Kubernetes Service, Amazon EKS, to host the order processing backend. B. Create a custom AWS Lambda runtime to mimic the web server environment. Create an Amazon API Gateway API to replace the front-end web servers. Set up Amazon MQ to replace the on-premises messaging queue. Configure Amazon Elastic Kubernetes Service, Amazon EKS, to host the order processing backend. C. Create an AMI of the web server VM. Create an Amazon EC2 auto-scaling group that uses the AMI and an application load balancer. Set up Amazon MQ to replace the on-premises messaging queue. Install Kubernetes on a fleet of different EC2 instances to host the order processing backend. D. Create an AMI of the web server VM. Create an Amazon EC2 auto-scaling group that uses the AMI and an application load balancer. Set up an Amazon Simple Queue service, Amazon SQS to replace the on-premises messaging queue. Configure Amazon Elastic Kubernetes Service, Amazon EKS, to host the order processing backend. A company has migrated its forms processing application to AWS. When users interact with the application, they upload scanned forms as files through a web application. A database stores user metadata and references to files that are stored in Amazon S3. The web application runs on Amazon EC2 instances and an Amazon RDS for PostgreSQL database. When forms are uploaded, the application sends notifications to a team through Amazon Simple Notification Service, Amazon SNS. A team member then logs in and processes each form. The team member performs data validation on the form and extracts relevant data before entering the information into another system that uses an API. A solutions architect needs to automate the manual processing of the forms. The solution must provide accurate form extraction, minimize time to market, and minimize long-term operational overhead. Which solution will meet these requirements? A company is running an application in the AWS cloud. The application collects and stores a large amount of unstructured data in an Amazon S3 bucket. The S3 bucket contains several terabytes of data and uses the S3 standard storage class. The data increases in size by several gigabytes every day. The company needs to query and analyze the data. The company does not access data that is more than 1 year old. However, The company must retain all the data indefinitely for compliance reasons. Which solution will meet these requirements most cost-effectively? A. Use S3 Select to query the data. Create an S3 lifecycle policy to transition data that is more than 1 year old to S3 Glacier Deep Archive. B. Use Amazon Redshift Spectrum to query the data. Create an S3 lifecycle policy to transition data that is more than 1 year old 10 S3 Glacier Deep Archive. C. Use an AWS Glue Data Catalog and Amazon Athena to query the data. Create an S3 lifecycle policy to transition data that is more than 1 year old to S3 Glacier Deep Archive. D. Use Amazon Redshift Spectrum to query the data. Create an S3 lifecycle policy to transition data that is more than 1 year old to S3 Intelligent Tiering. A company has an application that runs on Amazon EC2 instances. A solutions architect is designing VPC infrastructure in an AWS region where the application needs to access an Amazon Aurora DB cluster. The EC2 instances are all associated with the same security group. The DB cluster is associated with its own security group. The solutions architect needs to add rules to the security groups to provide the application with least privilege access to the DB cluster. Which combination of steps will meet these requirements? Choose 2. A. Add an inbound rule to the EC2 instance's security group. Specify the DB cluster's security group as the source over the default Aurora port. B. Add an outbound rule to the EC2 instance's security group. Specify the DB cluster's security group as the destination over the default Aurora port. C. Add an inbound rule to the DB cluster's security group. Specify the EC2 instance's security group as the source over the default Aurora port. D. Add an outbound rule to the DB cluster's security group. Specify the EC2 instance's security group as the destination over the default Aurora port. E. Add an outbound rule to the DB cluster's security group. Specify the EC2 instance's security group as the destination over the ephemeral ports. A company uses Amazon S3 to store files and images in a variety of storage classes. The company's S3 costs have increased substantially during the past year. A solutions architect needs to review data trends for the past 12 months and identify the appropriate storage class for the objects. Which solution will meet these requirements? A. Download AWS cost and usage reports for the last 12 months of S3 usage. Review AWS Trusted Advisor recommendations for cost savings. B. Use S3 storage class analysis. Import data trends into an Amazon QuickSight dashboard to analyze storage trends. C. Use Amazon S3 Storage Lens. Upgrade the default dashboard to include advanced metrics for storage trends. D. Use Access Analyzer for S3. Download the Access Analyzer for S3 report for the last 12 months. Import the .csv file to an Amazon QuickSight dashboard. Example Corp has an on-premises data center and a VPC named VPCA in the Example Corp AWS account. The on-premises network connects to VPCA through an AWS site-to-site VPN. The on-premises servers can properly access VPCA. Example Corp just acquired any company which has a VPC named VPCB. B. There is no IP address overlap among these networks. Example Corp has paired VPCA and VPCB. Example Corp wants to connect from its on-premise servers to VPCB. Example Corp has properly set up the network ACL and security groups. Which solution will meet this requirement with the least operational effort? A. Create a transit gateway. Attach the site-to-site VPN, VPCA, and VPCB to the transit gateway. Update the transit gateway route tables for all networks to add IP range routes for all other networks. B. Create a transit gateway. Create a site-to-site VPN connection between the on-premises network and VPCB, and connect the VPN connection to the transit gateway. Add a route to direct traffic to the peered VPCs, and add an authorization rule to give clients access to the VPCs A and BC. Update the route tables for the site-to-site VPN and both VPCs for all three networks. Configure BGP propagation for all three networks. Wait for up to 5 minutes for BGP propagation to finish. D. Modify the site-to-site VPN's virtual private gateway definition to include VPCA and VPCB. Split the two routers of the virtual private gateway between the two VPCs. A solutions architect is designing the data storage and retrieval architecture for a new application that a company will be launching soon. The application is designed to ingest millions of small records per minute from devices all around the world. Each record is less than 4 kilobytes in size and needs to be stored in a durable location where it can be retrieved with low latency. The data is ephemeral, and the company is required to store the data for 120 days only, after which the data can be deleted. The solutions architect calculates that during the course of a year, the storage requirements would be about 10 to 15 terabytes. Which storage strategy is the most cost-effective and meets the design requirements? A. Design the application to store each incoming record as a single .csv file in an Amazon S3 bucket to allow for indexed retrieval. Configure a lifecycle policy to delete data older than 120 days. B. Design the application to store each incoming record in an Amazon DynamoDB table properly configured for the scale. Configure the DynamoDB time to live (TTL) feature to delete records older than 120 days. C. Design the application to store each incoming record in a single table in an Amazon RDS MySQL database. Run a nightly cron job that runs a query to delete any records older than 120 days. D. Design the application to batch incoming records before writing them to an Amazon S3 bucket. Update the metadata for the object to contain the list of records in the batch, and use the Amazon S3 metadata search feature to retrieve the data. Configure a lifecycle policy to delete the data after 120 days. A company is running several workloads in a single AWS account. A new company policy states that engineers can provision only approved resources, and that engineers must use AWS CloudFormation to provision these resources. A solutions architect needs to create a solution to enforce the new restriction on the IAM role that the engineers use for access. What should the solutions architect do to create the solution? A. Upload AWS CloudFormation templates that contain approved resources to an Amazon S3 bucket. Update the IAM policy for the engineer's IAM role to only allow access to Amazon S3 and AWS CloudFormation. Use AWS CloudFormation templates to provision resources. B. Update the IAM policy for the engineer's IAM role with permissions to only allow provisioning of approved resources and AWS CloudFormation. Use AWS CloudFormation templates to create stacks with approved resources. C. Update the IAM policy for the engineer's IAM role with permissions to only allow AWS CloudFormation actions. Create a new IAM policy with permission to provision approved resources and assign the policy to a new IAM service role. Assign the IAM service role to AWS CloudFormation during stack creation. D. Provision resources in AWS CloudFormation stacks. Update the IAM policy for the engineer's IAM role to only allow access to their own AWS CloudFormation stack. A company is building a solution in the AWS cloud. Thousands of devices will connect to the solution and send data. Each device needs to be able to send and receive data in real time over the MQTT protocol. Each device must authenticate by using a unique X.509 certificate. Which solution will meet these requirements with the least operational overhead? A. Set up AWS IoT Core. For each device, create a corresponding Amazon MQ and provision a certificate. Connect each device to Amazon MQ. B. Create a network load balancer, NLB, and configure it with an AWS Lambda authorizer. Run an MQTT broker on Amazon EC2 instances in an autoscaling group. Set the autoscaling group as the target for the NL. Connect each device to the NLB. C. Set up AWS IoT Core. For each device, create a corresponding AWS IoT thing and provision a certificate. Connect each device to AWS IoT Core. D. Set up an Amazon API Gateway, HTTP API, and a Network Load Balancer, NLB. Create integration between API Gateway and the NLB. Configure a mutual TLS certificate authorizer on the HTTP API. Run an MQTT broker on an Amazon EC2 instance that the NLB targets. Connect each device to the NLB. A company is building a serverless application that runs on an AWS Lambda function that is attached to a VPC. The company needs to integrate the application with a new service from an external provider. The external provider supports only requests that come from public IPv4 addresses that are in an allow list. The company must provide a single public IP address to the external provider before the application can start using the new service. Which solution will give the application the ability to access the new service? A. Deploy a NAT gateway. Associate an elastic IP address with the NAT gateway. Configure the VPC to use the NAT gateway. B. Deploy an egress-only Internet gateway. Associate an elastic IP address with the egress-only Internet gateway. Configure the elastic network interface on the Lambda function to use the egress-only Internet gateway. C. Deploy an Internet gateway. Associate an elastic IP address with the Internet gateway. Configure the Lambda function to use the Internet gateway. D. Deploy an Internet gateway. Associate an elastic IP address with the Internet gateway. Configure the default route in the public VPC route table to use the Internet gateway. A company has an environment that has a single AWS account. A solutions architect is reviewing the environment to recommend what the company could improve specifically in terms of access to the AWS Management Console. The company's IT support workers currently access the console for administrative tasks, authenticating with named IAM users that have been mapped to their job role. The IT support workers no longer want to maintain both their Active Directory and IAM user accounts. They want to be able to access the console by using their existing Active Directory credentials. The solutions architect is using AWS IAM Identity Center, AWS Single Sign-On, to implement this functionality. Which solution will meet these requirements most cost-effectively? A company that uses AWS organizations allows developers to experiment on AWS. As part of the landing zone that the company has deployed, developers use their company email address to request an account. The company wants to ensure that developers are not launching costly services or running services unnecessarily. The company must give developers a fixed monthly budget to limit their AWS costs. Which combination of steps will meet these requirements? Choose 3. A. Create an SCP to set a fixed monthly account usage limit. Apply the SCP to the developer accounts. B. Use AWS budgets to create a fixed monthly budget for each developer's account as part of the account creation process. C. Create an SCP to deny access to costly services and components. Apply the SCP to the developer accounts. D. Create an IAM policy to deny access to costly services and components. Apply the IAM policy to the developer accounts. E. Create an AWS budgets alert action to terminate services when the budgeted amount is reached. Configure the action to terminate all services. F. Create an AWS budgets alert action to send an Amazon Simple Notification Service, Amazon SNS notification, when the budgeted amount is reached. Invoke an AWS Lambda function to terminate all services. A startup company hosts a fleet of Amazon EC2 instances in private subnets using the latest Amazon Linux 2 AMI. The company's engineers rely heavily on SSH access to the instances for troubleshooting. The company's existing architecture includes the following: AVPC with private and public subnets, and a NAT gateway. Site-to-site VPN for connectivity with the on-premises environment. EC2 security groups with direct SSH access from the on-premises environment. The company needs to increase security controls around SSH access and provide auditing of commands run by the engineers. Which strategy should a solutions architect use? A. Install and configure EC2 Instance Connect on the fleet of EC2 instances. Remove all security group rules attached to EC2 instances that allow inbound TCP on port 22. Advise the engineers to remotely access the instances by using the EC2 Instance Connect CLI. B. Update the EC2 security groups to only allow inbound TCP on port 22 to the IP addresses of the engineer's devices. Install the Amazon CloudWatch agent on all EC2 instances and send operating system audit logs to CloudWatch logs. C. Update the EC2 security groups to only allow inbound TCP on port 22 to the IP addresses of the engineer's devices. Enable AWS config for EC2 security group resource changes. Enable AWS Firewall Manager and apply a security group policy that automatically remediates changes to rules. D. Create an IAM role with the Amazon SSM Managed Instance Core Managed policy attached. Attach the IAM role to all the EC2 instances. Remove all security group rules attached to the EC2 instances that allow inbound TCP on port 22. Have the engineers install the AWS Systems Manager Session Manager plugin for their devices and remotely access the instances by using the Start Session API call from Systems Manager. A video processing company has an application that downloads images from an Amazon S3 bucket, processes the images, stores a transformed image in a second S3 bucket, and updates metadata about the image in an Amazon DynamoDB table. The application is written in Node.js and runs by using an AWS Lambda function. The Lambda function is invoked when a new image is uploaded to Amazon S3. The application ran without incident for a while. However, the size of the images has grown significantly. The Lambda function is now failing frequently with timeout errors. The function timeout is set to its maximum value. A solutions architect needs to refactor the application's architecture to prevent invocation failures. The company does not want to manage the underlying infrastructure. Which combination of steps should the solutions architect take to meet these requirements? Choose 2. A. Modify the application deployment by building a Docker image that contains the application code. Publish the image to Amazon Elastic Container Registry, Amazon ECR. B. Create a new Amazon Elastic Container Service, Amazon ECS, task definition, with a compatibility type of AWS Fargate. Configure the task definition to use the new image in Amazon Elastic Container Registry, Amazon ECR. Adjust the Lambda function to invoke an ECS task by using the ECS task definition when a new file arrives in Amazon S3. C. Create an AWS step functions state machine with a parallel state to invoke the Lambda function. Increase the provisioned concurrency of the Lambda function. D. Create a new Amazon Elastic Container Service, Amazon ECS, task definition, with a compatibility type of Amazon EC2. Configure the task definition to use the new image in Amazon Elastic Container Registry, Amazon ECR. Adjust the Lambda function to invoke an ECS task by using the ECS task definition when a new file arrives in Amazon S3. E. Modify the application to store images on Amazon Elastic File System, Amazon EFS, and to store metadata on an Amazon RDSDB instance. Adjust the Lambda function to mount the EFS file share. A company with several AWS accounts is using AWS Organizations and Service Control Policies, SCPs. An administrator created the following SCP and has attached it to an organizational unit, OU, that contains AWS account 111111111. Developers working in account 111111111 complain that they cannot create Amazon S3 buckets. How should the administrator address this problem? A. Add S3. Create bucket with allow effect to the SCP. B. Remove the account from the OU and attach the SCP directly to account 1111111111111. C. Instruct the developers to add Amazon S3 permissions to their IAM entities. D. Remove the SCP from account 111111111111. A company is running an application in the AWS cloud. Recent application metrics show inconsistent response times and a significant increase in error rates. Calls to third-party services are causing the delays. Currently, the application calls third-party services synchronously by directly invoking an AWS Lambda function. A solutions architect needs to decouple the third-party service calls and ensure that all the calls are eventually completed. Which solution will meet these requirements? A. Use an Amazon Simple Queue service, Amazon SQS, queue to store events and invoke the Lambda function. B. Use an AWS step function state machine to pass events to the Lambda function. C. Use an Amazon Event Bridge rule to pass events to the Lambda function. D. Use an Amazon Simple Notification Service, Amazon SNS topic, to store events and invoke the Lambda function. An e-commerce company is revamping its IT infrastructure and is planning to use AWS services. The company's CIO has asked a solutions architect to design a simple, highly available, and loosely coupled order processing application. The application is responsible for receiving and processing orders before storing them in an Amazon DynamoDB table. The application has a sporadic traffic pattern and should be able to scale during marketing campaigns to process the orders with minimal delays. Which of the following is the most reliable approach to meet the requirements? A. Receive the orders in an Amazon EC2 hosted database and use EC2 instances to process them. B. Receive the orders in an Amazon SQS queue and invoke an AWS Lambda function to process them. C. Receive the orders using the AWS Step Functions program and launch an Amazon ECS container to process them. A. Receive the orders in Amazon Kinesis data streams and use Amazon EC2 instances to process them. A solutions architect has developed a web application that uses an Amazon API Gateway regional endpoint and an AWS Lambda function. The consumers of the web application are all close to the AWS region where the application will be deployed. The Lambda function only queries an Amazon Aurora MySQL database. The solutions architect has configured the database to have 3 read replicas. During testing, the application does not meet performance requirements. Under high load, the application opens a large number of database connections. The solutions architect must improve the application's performance. Which actions should the solutions architect take to meet these requirements? Choose 2. A. Use the cluster endpoint of the Aurora database. B. Use RDS proxy to set up a connection pool to the reader endpoint of the Aurora database. C. Use the Lambda provisioned concurrency feature. D. Move the code for opening the database connection in the Lambda function outside of the event handler. E. Change the API Gateway endpoint to an edge-optimized endpoint. A company is planning to migrate 1,000 on-premises servers to AWS. The servers run on several VMware clusters in the company's data center. As part of the migration plan, the company wants to gather server metrics such as CPU details, RAM usage, operating system information, and running processes. The company then wants to query and analyze the data. Which solution will meet these requirements? A. Deploy and configure the AWS Agentless Discovery Connector virtual appliance on the on-premises hosts. Configure data exploration in AWS Migration Hub. Use AWS Glue to perform an ETL job against the data. Query the data by using Amazon S3 Select. B. Export only the VM performance information from the on-premises hosts. Directly import the required data into AWS Migration Hub. Update any missing information in Migration Hub. Query the data by using Amazon QuickSight. C. Create a script to automatically gather the server information from the on-premises hosts. Use the AWS CLI to run the Put Resource Attributes command to store the detailed server data in AWS Migration Hub. Query the data directly in the Migration Hub console. D. Deploy the AWS Application Discovery Agent to each on-premises server. Configure data exploration in AWS Migration Hub. Use Amazon Athena to run predefined queries against the data in Amazon S3. A company wants to migrate its workloads from on-premises to AWS. The workloads run on Linux and Windows. The company has a large on-premises infrastructure that consists of physical machines and VMs that host numerous applications. The company must capture details about the system configuration, system performance, running processes, and network connections of its on-premises workloads. The company also must divide the on-premises applications into groups for AWS migrations. The company needs recommendations for Amazon EC2 instance types so that the company can run its workloads on AWS in the most cost-effective manner. Which combination of steps should a solutions architect take to meet these requirements? Choose 3. A. Assess the existing applications by installing AWS Application Discovery Agent on the physical machines and VMs. B. Assess the existing applications by installing AWS Systems Manager Agent on the physical machines and VMs. C. Group servers into applications for migration by using AWS Systems Manager, Application Manager. D. Group servers into applications for migration by using AWS Migration Hub. E. Generate recommended instance types and associated costs by using AWS Migration Hub. F. Import data about server sizes into AWS Trusted Advisor. Follow the recommendations for cost optimization. A company has 50 AWS accounts that are members of an organization in AWS organizations. Each account contains multiple VPCs. The company wants to use AWS Transit Gateway to establish connectivity between the VPCs in each member account. Each time a new member account is created, the company wants to automate the process of creating a new VPC and a Transit Gateway attachment. Which combination of steps will meet these requirements? Choose 2. A. From the management account, share the Transit Gateway with member accounts by using AWS Resource Access Manager. B. From the management account, share the Transit Gateway with member accounts by using an AWS organization's SCP. C. Launch an AWS CloudFormation stack set from the management account that automatically creates a new VPC and a VPC Transit Gateway attachment in a member account. Associate the attachment with the Transit Gateway in the management account by using the Transit Gateway ID. D. Launch an AWS CloudFormation stack set from the management account that automatically creates a new VPC and a peering Transit Gateway attachment in a member account. Share the attachment with the Transit Gateway in the management account by using a Transit Gateway service-linked role. E. From the management account, share the Transit Gateway with member accounts by using AWS Service Catalog. A company that has multiple AWS accounts is using AWS organizations. The company's AWS accounts host VPCs, Amazon EC2 instances, and containers. The company's compliance team has deployed a security tool in each VPC where the company has deployments. The security tools run on EC2 instances and send information to the AWS account that is dedicated for the compliance team. The company has tagged all the compliance-related resources with a key of cost center and a value or compliance. The company wants to identify the cost of the security tools that are running on the EC2 instances so that the company can charge the compliance team's AWS account. The cost calculation must be as accurate as possible. What should a solutions architect do to meet these requirements? A. In the management account of the organization, activate the Cost Center user-defined tag. Configure monthly AWS cost and usage reports to save to an Amazon S3 bucket in the management account. Use the tag breakdown in the report to obtain the total cost for the Cost Center tagged resources. B. In the member accounts of the organization, activate the Cost Center user-defined tag. Configure monthly AWS cost and usage reports to save to an Amazon S3 bucket in the management account. Schedule a monthly AWS Lambda function to retrieve the reports and calculate the total cost for the cost center tagged resources. C. In the member accounts of the organization, activate the cost center user-defined tag. From the management account, schedule a monthly AWS cost and usage report. Use the tag breakdown in the report to calculate the total cost for the cost center tagged resources. D. Create a custom report in the organization view in AWS Trusted Advisor. Configure the report to generate a monthly billing summary for the cost center tagged resources in the compliance team's AWS account. A company is storing data in several Amazon DynamoDB tables. A solutions architect must use a serverless architecture to make the data accessible publicly through a simple API over HTTPS. The solution must scale automatically in response to demand. Which solutions meet these requirements? Choose 2. A. Create an Amazon API Gateway REST API. Configure this API with direct integrations to DynamoDB by using API Gateway's AWS integration type. B. Create an Amazon API Gateway HTTP API. Configure this API with direct integrations to DynamoDBs by using API Gateway's AWS integration type. C. Create an Amazon API Gateway HTTP API. Configure this API with integrations to AWS Lambda functions that return data from the DynamoDB tables. D. Create an accelerator in AWS Global Accelerator. Configure this accelerator with AWS Lambda at edge function integrations that return data from the DynamoDB tables. E. Create a network load balancer. Configure listener rules to forward requests to the appropriate AWS Lambda functions. A company uses an on-premises data analytics platform. The system is highly available in a fully redundant configuration across 12 servers in the company's data center. The system runs scheduled jobs, both hourly and daily, in addition to one-time requests from users. Scheduled jobs can take between 20 minutes and 2 hours to finish running and have tight SLAs. The scheduled jobs account for 65% of the system usage. User jobs typically finish running in less than 5 minutes and have no SLA. The user jobs account for 35% of system usage. During system failures, scheduled jobs must continue to meet SLAs. However, user jobs can be delayed. A solutions architect needs to move the system to Amazon EC2 instances and adopt a consumption-based model to reduce costs with no long-term commitments. The solution must maintain high availability and must not affect the SLAs. Which solution will meet these requirements most cost-effectively? A. Split the 12 instances across 2 availability zones in the chosen AWS region. Run 2 instances in each availability zone as on-demand instances with capacity reservations. Run 4 instances in each availability zone as spot instances. B. Split the 12 instances across 3 availability zones in the chosen AWS region. In one of the availability zones, run all 4 instances as on-demand instances with capacity reservations. Run the remaining instances as spot instances. C. Split the 12 instances across 3 availability zones in the chosen AWS region. Run 2 instances in each availability zone as on-demand instances with a savings plan. Run 2 instances in each availability zone as spot instances. D. Split the 12 instances across 3 availability zones in the chosen AWS region. Run 3 instances in each availability zone as on-demand instances with capacity reservations. Run one instance in each availability zone as a spot instance. A company is running a data-intensive application on AWS. The application runs on a cluster of hundreds of Amazon EC2 instances. A shared file system also runs on several EC2 instances that store 200 NBSP TB of data. The application reads and modifies the data on the shared file system and generates a report. The job runs once monthly, reads a subset of the files from the shared file system, and takes about 72 NBSP hours to complete. The compute instances scale in an auto-scaling group, but the instances that host the shared file system run continuously. The compute and storage instances are all in the same AWS region. A solutions architect needs to reduce costs by replacing the shared file system instances. The file system must provide high-performance access to the needed data for the duration of the 72-hour run. Which solution will provide the largest overall cost reduction while meeting these requirements? A software company has deployed an application that consumes a REST API by using Amazon API Gateway, AWS Lambda functions, and an Amazon DynamoDB table. The application is showing an increase in the number of errors during PUT requests. Most of the PUT calls come from a small number of clients that are authenticated with specific API keys. A solutions architect has identified that a large number of the PUT requests originate from one client. The API is non-critical, and clients can tolerate retries of unsuccessful calls. However, the errors are displayed to customers and are causing damage to the API's reputation. What should the solutions architect recommend to improve the customer experience? A. Implement retry logic with exponential backoff and irregular variation in the client application. Ensure that the errors are caught and handled with descriptive error messages. B. Implement API throttling through a usage plan at the API gateway level. Ensure that the client application handles code 429 replies without error. C. Turn on API caching to enhance responsiveness for the production stage. Run 10-minute load tests. Verify that the cache capacity is appropriate for the workload. D. Implement reserved concurrency at the Lambda function level to provide the resources that are needed during sudden increases in traffic. A company has a serverless application comprised of Amazon CloudFront, Amazon API Gateway, and AWS Lambda functions. The current deployment process of the application code is to create a new version number of the Lambda function and run an AWS CLI script to update. If the new function version has errors, another CLI script reverts by deploying the previous working version of the function. The company would like to decrease the time to deploy new versions of the application logic provided by the Lambda functions, and also reduce the time to detect and revert when errors are identified. How can this be accomplished? A. Create and deploy nested AWS CloudFormation stacks with the parent stack consisting of the AWS CloudFront distribution and API gateway, and the child stack containing the Lambda function. For changes to Lambda, create an AWS CloudFormation change set and deploy. If errors are triggered, revert the AWS CloudFormation change set to the previous version. B. Use AWS SAM and built-in AWS code deploy to deploy the new Lambda version. Gradually shift traffic to the new version and use pre-traffic and post-traffic test functions to verify code. Rollback if Amazon CloudWatch alarms are triggered. C. Refactor the AWS CLI scripts into a single script that deploys the new Lambda version. When deployment is completed, the script tests execute. If errors are detected, revert to the previous Lambda version. D. Create and deploy an AWS CloudFormation stack that consists of a new API gateway endpoint that references the new Lambda version. Change the CloudFront origin to the new API gateway endpoint. Monitor errors and, if detected, change the AWS CloudFront origin to the previous API gateway endpoint. A company is running an application on several Amazon EC2 instances in an autoscaling group behind an application load balancer. The load on the application varies throughout the day, and EC2 instances are scaled in and out on a regular basis. Log files from the EC2 instances are copied to a central Amazon S3 bucket every 15 minutes. The security team discovers that log files are missing from some of the terminated EC2 instances. Which set of actions will ensure that log files are copied to the central S3 bucket from the terminated EC2 instances? A. Create a script to copy log files to Amazon S3 and store the script in a file on the EC2 instance. Create an autoscaling lifecycle hook and an Amazon event bridge rule to detect lifecycle events from the autoscaling group. Invoke an AWS Lambda function on the autoscaling EC2_instance_terminating transition to send abandon to the autoscaling group to prevent termination. Run the script to copy the log files and terminate the instance using the AWS SDK. B. Create an AWS Systems Manager document with a script to copy log files to Amazon S3. Create an autoscaling lifecycle hook and an Amazon event bridge rule to detect lifecycle events from the autoscaling group. Invoke an AWS Lambda function on the autoscaling EC2_instance_terminating transition to call the AWS Systems Manager API send command operation to run the document to copy the log files and send continue to the autoscaling group to terminate the instance. C. Change the log delivery rate to every 5 minutes. Create a script to copy log files to Amazon S3 and add the script to EC2 instance user data. Create an Amazon event bridge rule to detect EC2 instance termination. Invoke an AWS Lambda function from the event bridge rule that uses the AWS CLI to run the user data script to copy the log files and terminate the instance. D. Create an AWS Systems Manager document with a script to copy log files to Amazon S3. Create an auto-scaling lifecycle hook that publishes a message to an Amazon Simple Notification Service, Amazon SNS, topic. From the SNS notification, call the AWS Systems Manager API, send command operation to run the document to copy the log files, and send abandon to the autoscaling group to terminate the instance. A company needs to implement a patching process for its servers. The on-premises servers and Amazon EC2 instances use a variety of tools to perform patching. The management requires a single report showing the patch status of all the servers and instances. Which set of actions should a solutions architect take to meet these requirements? A. Use AWS Systems Manager to manage patches on the on-premises servers and EC2 instances. Use Systems Manager to generate patch compliance reports. B. Use AWS OpsWorks to manage patches on the on-premises servers and EC2 instances. Use Amazon QuickSight integration with OpsWorks to generate patch compliance reports. C. Use an Amazon Event Bridge rule to apply patches by scheduling an AWS Systems Manager patch remediation job. Use Amazon Inspector to generate patch compliance reports. D. Use AWS OpsWorks to manage patches on the on-premises servers and EC2 instances. Use AWS X-Ray to post the patch status to AWS Systems Manager Ops Center to generate patch compliance reports. A company wants to use a third-party software as a service SaaS application. The third-party SaaS application is consumed through several API calls. The third-party SaaS application also runs on AWS inside of VPC. The company will consume the third-party SaaS application from inside of VPC. The company has internal security policies that mandate the use of private connectivity that does not traverse the internet. No resources that run in the company VPC are allowed to be accessed from outside the company's VPC. All permissions must conform to the principles of least privilege. Which solution meets these requirements? A. Create an AWS Private Link Interface VPC endpoint. Connect this endpoint to the endpoint service that the third-party SaaS application provides. Create a security group to limit the access to the endpoint. Associate the security group with the endpoint. B. Create an AWS site-to-site VPN connection between the third-party SaaS application and the company VPC. Configure network ACLs to limit access across the VPN tunnels. C. Create a VPC peering connection between the third-party SaaS application and the company VP update route tables by adding the needed routes for the peering connection. D. Create an AWS Private Link Endpoint service. Ask the third-party SaaS provider to create an interface VPC endpoint for this endpoint service. Grant permissions for the endpoint service to the specific account of the third-party SaaS provider. A company has a multi-tier web application that runs on a fleet of Amazon EC2 instances behind an application load balancer, ALB. The instances are in an auto-scaling group. The ALB and the auto-scaling group are replicated in a backup AWS region. The minimum value and the maximum value for the auto-scaling group are set to 0. An Amazon RDS multi-AZ DB instance stores the application's data. The DB instance has a read replica in the backup region. The application presents an endpoint to end users by using an Amazon Route 53 record. The company needs to reduce its RTO to less than 15 minutes by giving the application the ability to automatically fail over to the backup region. The company does not have a large enough budget for an active-active strategy. What should a solutions architect recommend to meet these requirements? A company is running a two-tier web-based application in an on-premises data center. The application layer consists of a single server running a stateful application. The application connects to a PostgreSQL database running on a separate server. The application's user base is expected to grow significantly, so the company is migrating the application and database to AWS. The solution will use Amazon Aurora PostgreSQL, Amazon EC2 autoscaling, and elastic load balancing. Which solution will provide a consistent user experience that will allow the application and database tiers to scale? A. Enable Aurora autoscaling for Aurora replicas. Use a network load balancer with the least outstanding requests, routing algorithm, and sticky sessions enabled. B. Enable Aurora autoscaling for Aurora writers. Use an application load balancer with a round-robin routing algorithm and sticky sessions enabled. C. Enable Aurora autoscaling for Aurora replicas. Use an application load balancer with the round-robin routing and sticky sessions enabled. D. Enable Aurora scaling for Aurora writers. Use a network load balancer with the least outstanding requests, routing algorithm, and sticky sessions enabled. A company uses AWS CloudFormation to deploy applications within multiple VPCs that are all attached to a transit gateway. Each VPC that sends traffic to the public internet must send the traffic through a shared services VPC. Each subnet within a VPC uses the default VPC route table, and the traffic is routed to the transit gateway. The transit gateway uses its default route table for any VPC attachment. A security audit reveals that an Amazon EC2 instance that is deployed within a VPC can communicate with an EC2 instance that is deployed in any of the company's other VPCs. A solutions architect needs to limit the traffic between the VPCs. Each VPC must be able to communicate only with a predefined, limited set of authorized VPCs. What should the solutions architect do to meet these requirements? A. Update the network ACL of each subnet within a VPC to allow outbound traffic only to the authorized VPCs. Remove all deny rules except the default deny rule. B. Update all the security groups that are used within a VPC to deny outbound traffic to security groups that are used within the unauthorized VPCs. C. Create a dedicated transit gateway route table for each VPC attachment. Route traffic only to the authorized VPCs. D. Update the main route table of each VPC to route traffic only to the authorized VPCs through the transit gateway. A company with global offices has a single one and NBSP, GBP's AWS Direct Connect connection to a single AWS region. The company's on-premises network uses the connection to communicate with the company's resources in the AWS cloud. The connection has a single private virtual interface that connects to a single VPC. A solutions architect must implement a solution that adds a redundant direct connect connection in the same region. The solution also must provide connectivity to other regions through the same pair of direct connect connections as the company expands into other regions. Which solution meets these requirements? A. Provision a direct connect gateway. Delete the existing private virtual interface from the existing connection. Create the second direct connect connection. Create a new private virtual interface on each connection and connect both private virtual interfaces to the direct connect gateway. Connect the direct connect gateway to the single VPC. B. Keep the existing private virtual interface. Create the second direct connect connection. Create a new private virtual interface on the new connection and connect the new private virtual interface to the single VPC. C. Keep the existing private virtual interface. Create the second direct connect connection. Create a new public virtual interface on the new connection and connect the new public virtual interface to the single VPC. D. Provision a transit gateway. Delete the existing private virtual interface from the existing connection. Create the second direct connect connection. Create a new private virtual interface on each connection and connect both private virtual interfaces to the transit gateway. Associate the transit gateway with the single VPC. A company recently started hosting new application workloads in the AWS cloud. The company is using Amazon EC2 instances, Amazon Elastic File System, Amazon EFS file systems, and Amazon RDS-DB instances. To meet regulatory and business requirements, the company must make the following changes for data backups. Backups must be retained based on custom daily, weekly, and monthly requirements. Backups must be replicated to at least one other AWS region immediately after capture. The backup solution must provide a single source of backup status across the AWS environment. The backup solution must send immediate notifications upon failure of any resource backup. Which combination of steps will meet these requirements with the least amount of operational overhead? Choose 3. A. Create an AWS backup plan with a backup rule for each of the retention requirements. B. Configure an AWS backup plan to copy backups to another region. C. Create an AWS Lambda function to replicate backups to another region and send notification if a failure occurs. D. Add an Amazon Simple Notification Service, Amazon SNS topic, to the backup plan to send a notification for finished jobs that have any status except backup_job_completed. E. Create an Amazon Data Lifecycle Manager, Amazon DLM, snapshot lifecycle policy for each of the retention requirements. F. Set up RDS snapshots on each database. A company wants to use AWS for disaster recovery for an on-premises application. The company has hundreds of Windows-based servers that run the application. All the servers mount a common share. The company has an RTO of 15 minutes and an RPO of 5 minutes. The solution must support native failover and fallback capabilities. Which solution will meet these requirements most cost-effectively? A. Create an AWS Storage Gateway File Gateway. Schedule daily Windows Server backups. Save the data to Amazon S3. During a disaster, recover the on-premises servers from the backup. During tailback, run the on-premises servers on Amazon EC2 instances. B. Create a set of AWS CloudFormation templates to create infrastructure. Replicate all data to Amazon Elastic File System, Amazon EFS, by using AWS DataSync. During a disaster, use AWS Code Pipeline to deploy the templates to restore the on-premises servers. Failback the data by using DataSync. C. Create an AWS Cloud Development Kit, AWS CDK pipeline, to stand up a multi-site active environment on AWS. Replicate data into Amazon S3 by using the S3 sync command. During a disaster, swap DNS endpoints to point to AWS. Fail back the data by using the S3 sync command. D. Use AWS Elastic Disaster Recovery to replicate the on-premises servers. Replicate data to an Amazon FSx for Windows File Server file system by using AWS DataSync. Mount the file system to AWS servers. During a disaster, fail over the on-premises servers to AWS. Fail back to new or existing servers by using Elastic Disaster Recovery. A company needs to establish a connection from its on-premises data center to AWS. The company needs to connect all of its VPCs that are located in different AWS regions with transitive routing capabilities between VPC networks. The company also must reduce network outbound traffic costs, increase bandwidth throughput, and provide a consistent network experience for end users. Which solution will meet these requirements? A. Create an AWS site-to-site VPN connection between the on-premises data center and a new central VPC. Create VPC peering connections that initiate from the central VPC to all other VPCs. B. Create an AWS Direct Connect connection between the on-premises data center and AWS. Provision a transit VIF and connect it to a Direct Connect gateway. Connect the direct connect gateway to all the other VPCs by using a transit gateway in each region. C. Create an AWS site-to-site VPN connection between the on-premises data center and a new central VP. Use a transit gateway with dynamic routing. Connect the transit gateway to all other VPCs. D. Create an AWS Direct Connect connection between the on-premises data center and AWS. Establish an AWS site-to-site VPN connection between all VPCs in each region. Create VPC peering connections that initiate from the central VPC to all other VPCs. A retail company is operating its e-commerce application on AWS. The application runs on Amazon EC2 instances behind an application load balancer, ALB. The company uses an Amazon RDS-DB instance as the database backend. Amazon CloudFront is configured with one origin that points to the ALB. Static content is cached. Amazon Route 53 is used to host all public zones. After an update of the application, the ALB occasionally returns a 502 status code, bad gateway error. The root cause is malformed HTTP headers that are returned to the ALB. The web page returns successfully when a solutions architect reloads the web page immediately after the error occurs. While the company is working on the problem, the solutions architect needs to provide a custom error page instead of the standard ALB error page to visitors. Which combination of steps will meet this requirement with the least amount of operational overhead? Choose 2. A. Create an Amazon S3 bucket. Configure the S3 bucket to host a static web page. Upload the custom error pages to Amazon S3. B. Create an Amazon CloudWatch alarm to invoke an AWS Lambda function if the ALB health check response target failed health checks is greater than 0. Configure the Lambda function to modify the forwarding rule at the ALB to point to a publicly accessible web server. C. Modify the existing Amazon Route 53 records by adding health checks. Configure a fallback target if the health check fails. Modify DNS records to point to a publicly accessible web page. B. Create an Amazon CloudWatch alarm to invoke an AWS Lambda function if the ALB health check response, ELB, internal error is greater than 0. Configure the Lambda function to modify the forwarding rule at the ALB to point to a public accessible web server. E. Add a custom error response by configuring a CloudFront custom error page. Modify DNS records to point to a publicly accessible web page. A company is planning to migrate to the AWS cloud. The company hosts many applications on Windows servers and Linux servers. Some of the servers are physical, and some of the servers are virtual. The company uses several types of databases in its on-premises environment. The company does not have an accurate inventory of its on-premises servers and applications. The company wants to right-size its resources during migration. A solutions architect needs to obtain information about the network connections and the application relationships. The solutions architect must assess the company's current environment and develop a migration plan. Which solution will provide the solutions architect with the required information to develop the migration plan? A. Use Migration Evaluator to request an evaluation of the environment from AWS. Use the AWS Application Discovery Service Agentless Collector to import the details into a Migration Evaluator Quick Insights report. B. Use AWS Migration Hub and install the AWS Application Discovery Agent on the servers. Deploy the Migration Hub Strategy Recommendations Application Data Collector. Generate a report by using Migration Hub Strategy Recommendations. C. Use AWS Migration Hub and run the AWS Application Discovery Service agentless collector on the servers. Group the servers and databases by using AWS Application Migration Service. Generate a report by using Migration Hub Strategy Recommendations. D. Use the AWS Migration Hub import tool to load the details of the company's on-premises environment. Generate a report by using Migration Hub Strategy Recommendations. A solutions architect wants to cost optimize and appropriately size Amazon EC2 instances in a single AWS account. The solutions architect wants to ensure that the instances are optimized based on CPU, memory, and network metrics. Which combination of steps should the solutions architect take to meet these requirements? Choose 2. A. Purchase AWS Business Support or AWS Enterprise Support for the account. B. Turn on AWS Trusted Advisor and review any low-utilization Amazon EC2 instances recommendations. C. Install the Amazon CloudWatch agent and configure memory metric collection on the EC2 instances. D. Configure AWS Compute Optimizer in the AWS account to receive findings and optimization recommendations. E. Create an EC2 instance savings plan for the AWS regions, instance families, and operating systems of interest. A financial services company runs a complex, multi-tier application on Amazon EC2 instances and AWS Lambda functions. The application stores temporary data in Amazon S3. The S3 objects are valid for only 45 minutes and are deleted after 24 hours. The company deploys each version of the application by launching an AWS CloudFormation stack. The stack creates all resources that are required to run the application. When the company deploys and validates a new application version, the company deletes the CloudFormation stack of the old version. The company recently tried to delete the CloudFormation stack of an old application version, but the operation failed. An analysis shows that CloudFormation failed to delete an existing S3 bucket. A solutions architect needs to resolve this issue without making major changes to the application's architecture. Which solution meets these requirements? A. Implement a Lambda function that deletes all files from a given S3 bucket. Integrate this Lambda function as a custom resource into the CloudFormation stack. Ensure that the custom resource has a depends on attribute that points to the S3 bucket's resource. B. Modify the CloudFormation template to provision an Amazon Elastic file system, Amazon EFS file system, to store the temporary files there instead of an Amazon S3. Configure the Lambda functions to run in the same VPC as the file system. Mount the file system to the EC2 instances and Lambda functions. C. Modify the CloudFormation stack to create an S3 lifecycle rule that expires all objects 45 minutes after creation. Add a depends on attribute that points to the S3 bucket's resource. D. Modify the CloudFormation stack to attach a deletion policy attribute with a value of delete to the S3 bucket. A company has an application that runs on Amazon EC2 instances in an Amazon EC2 auto-scaling group. The company uses AWS Code Pipeline to deploy the application. The instances that run in the auto-scaling group are constantly changing because of scaling events. When the company deploys new application code versions, the company installs the AWS Code Deploy agent on any new target EC2 instances and associates the instances with the Code Deploy deployment group. The application is set to go live within the next 24 hours. What should a solutions architect recommend to automate the application deployment process with the least amount of operational overhead. A. Configure Amazon Event Bridge to invoke an AWS Lambda function when a new EC2 instance is launched into the auto-scaling group. Code the Lambda function to associate the EC2 instances with the code deploy deployment group. B. Write a script to suspend Amazon EC2 auto-scaling operations before the deployment of new code. When the deployment is complete, create a new AMI and configure the auto-scaling group's launch template to use the new AMI for new launches. Resume Amazon EC2 auto-scaling operations. C. Create a new AWS code build project that creates a new AMI that contains the new code. Configure code build to update the auto-scaling group's launch template to the new AMI. Run an Amazon EC2 auto-scaling instance refresh operation. D. Create a new AMI that has the code deploy agent installed. Configure the auto-scaling group's launch template to use the new AMI. Associate the code deploy deployment group with the auto-scaling group instead of the EC2 instances. A company has migrated a legacy application to the AWS cloud. The application runs on 3 Amazon EC2 instances that are spread across 3 availability zones. One EC2 instance is in each availability zone. The EC2 instances are running in 3 private subnets of the VPC and are set up as targets for an application load balancer (ALB) that is associated with 3 public subnets. The application needs to communicate with on-premises systems. Only traffic from IP addresses in the company's IP address range are allowed to access the on-premises systems. The company's security team is bringing only one IP address from its internal IP address range to the cloud. The company has added this IP address to the allow list for the company firewall. The company also has created an elastic IP address for this IP address. A solutions architect needs to create a solution that gives the application the ability to communicate with the on-premises systems. The solution also must be able to mitigate failures automatically. Which solution will meet these requirements? A retail company has structured its AWS accounts to be part of an organization in AWS organizations. The company has set up consolidated billing and has mapped its departments to the following OUs: finance, sales, human resources, HR, marketing, and operations. Each OU has multiple AWS accounts, one for each environment within a department. These environments are development, test, pre-production, and production. The HR department is releasing a new system that will launch in 3 months. In preparation, the HR department has purchased several reserved instances, RIs, in its production AWS account. The HR department will install the new application on this account. The HR department wants to make sure that other departments cannot share the RI discounts. Which solution will meet these requirements? A. In the AWS Billing and Cost Management Console, for the HR department's production account, turn off RI sharing. B. Remove the HR department's production AWS account from the organization. Add the account 10, the consolidating billing configuration only. C. In the AWS Billing and Cost Management Console, use the organization's management account 10 turn off RI sharing for the HR department's production AWS account. B. Create an SCP in the organization to restrict access to the RIs. Apply the SCP to the OUs of the other departments. A company uses AWS organizations for a multi-account setup in the AWS cloud. The company uses AWS Control Tower for governance and uses AWS Transit Gateway for VPC connectivity across accounts. In an AWS application account, the company's application team has deployed a web application that uses AWS Lambda and Amazon RDS. The company's database administrators have a separate DBA account and use the account to centrally manage all the databases across the organization. The database administrators use an Amazon EC2 instance that is deployed in the DBA account to access an RDS database that is deployed the application account. The application team has stored the database credentials as secrets in AWS Secrets Manager in the application account. The application team is manually sharing the secrets with the database administrators. The secrets are encrypted by the default AWS managed key for Secrets Manager in the application account. A solutions architect needs to implement a solution that gives the database administrators access to the database and eliminates the need to manually share the secrets. Which solution will meet these requirements? A company is processing videos in the AWS cloud by using Amazon EC2 instances in an autoscaling group. It takes 30 minutes to process a video. Several EC2 instances scale in and out depending on the number of videos in an Amazon Simple Queue service, Amazon SQS-Q. The company has configured the SQS-Q with a redrive policy that specifies a target dead letter queue and a max receive count of 1. The company has set the visibility timeout for the SQS-Q to 1 hour. The company has set up an Amazon CloudWatch alarm to notify the development team when there are messages in the dead letter queue. Several times during the day, the development team receives notification that messages are in the dead letter queue and that videos have not been processed properly. An investigation finds no errors in the application logs. How can the company solve this problem? A. Turn on termination protection toward the EC2 instances. B. Update the visibility timeout for the SQS-Q to 3 hours. C. Configure scale-in protection for the instances during processing. D. Update the redrive policy and set max receive count to 0. A company recently migrated a web application from an on-premises data center to the AWS cloud. The web application infrastructure consists of an Amazon CloudFront distribution that routes to an application load balancer, ALB, with Amazon Elastic Container Service, Amazon ECS, to process requests. A recent security audit revealed that the web application is accessible by using both CloudFront and ALB endpoints. However, the company requires that the web application must be accessible only by using the CloudFront endpoint. Which solution will meet this requirement with the least amount of effort? A. Create a new security group and attach it to the CloudFront distribution. Update the ALB security group ingress to allow access only from the CloudFront security group. B. Update ALB security group ingress to allow access only from the Amazon AWS Global CloudFront origin-facing CloudFront managed prefix list. C. Create a Amazon AWS region Elastic Load Balancing VPC interface endpoint for elastic load balancing. Update the ALB scheme from internet-facing to internal. D. Extract CloudFront IPs from the AWS-provided IP ranges. JSON document. Update ALB security group ingress to allow access only from CloudFront IPs. A company wants to migrate to AWS. The company wants to use a multi-account structure with centrally managed access to all accounts and applications. The company also wants to keep the traffic on a private network. Multi-factor authentication, MFA, is required at login, and specific roles are assigned to user groups. The company must create separate accounts for development, staging, production, and shared network. The production account and the shared network account must have connectivity to all accounts. The development account and the staging account must have access only to each other. Which combination of steps should a solutions architect take 10 meet these requirements? Choose 3. A. Deploy a landing zone environment by using AWS Control Tower. Enroll accounts and invite existing accounts into the resulting organization in AWS organizations. B. Enable AWS Security Hub in all accounts to manage cross-account access. Collect findings through AWS CloudTrail to force MFA login. C. Create transit gateways and transit gateway VPC attachments in each account. Configure appropriate route tables. D. Set up and enable AWS IAM Identity Center, AWS Single Sign-On. Create appropriate permission sets with required MFA for existing accounts. E. Enable AWS Control Tower in all accounts to manage routing between accounts. Collect findings through AWS CloudTrail to force MFA login. F. Create IAM users and groups. Configure MFA for all users. Set up Amazon Cognoto user pools and identity pools to manage access to accounts and between accounts. A company runs a new application as a static website in Amazon S3. The company has deployed the application to a production AWS account and uses Amazon CloudFront to deliver the website. The website calls an Amazon API Gateway REST API. An AWS Lambda function backs each API method. The company wants to create a CSV report every 2 weeks to show each API Lambda function's recommended configured memory, recommended cost, and the price difference between current configurations and the recommendations. The company will store the reports in an S3 bucket. Which solution will meet these requirements with the least development time? A. Create a Lambda function that extracts metrics data for each API Lambda function from Amazon CloudWatch logs for the 2-week period. Collate the data into tabular format. Store the data as a.csv file in an S3 bucket. Create an Amazon Event Bridge rule to schedule the Lambda function to run every 2 weeks. B. Opt-in to AWS Compute Optimizer. Create a Lambda function that calls the Export Lambda Function Recommendations operation. Export the .csv file to an S3 bucket. Create an Amazon Event Bridge rule to schedule the Lambda function to run every 2 weeks. C. Opt-in to AWS Compute Optimizer. Set up enhanced infrastructure metrics. Within the Compute Optimizer console, schedule a job to export the Lambda recommendations to a.csv file. Store the file in an S3 bucket every 2 weeks. D. Purchase the AWS Business Support Plan for the production account. Opt-in to AWS Compute Optimizer for AWS Trusted Advisor checks. In the Trusted Advisor console, schedule a job to export the cost optimization checks to a.csv file. Store the file in an S3 bucket every 2 weeks. A company has application services that have been containerized and deployed on multiple Amazon EC2 instances with public IPs. An Apache Kafka cluster has been deployed to the EC2 instances. A PostgreSQL database has been migrated to Amazon RDS for PostgreSQL. The company expects a significant increase of orders on its platform when a new version of its flagship product is released. What changes to the current architecture will reduce operational overhead and support the product release? A. Create an EC2 autoscaling group behind an application load balancer. Create additional read replicas for the DB instance. Create Amazon Kinesis data streams and configure the application services to use the data streams. Store and serve static content directly from Amazon S3. B. Create an EC2 autoscaling group behind an application load balancer. Deploy the DB instance in multi-AZ mode and enable storage autoscaling. Create Amazon Kinesis data streams and configure the application services to use the data streams. Store and serve static content directly from Amazon S3. C. Deploy the application on a Kubernetes cluster created on the EC2 instances behind an application load balancer. Deploy the DB instance in multi-AZ mode and enable storage autoscaling. Create an Amazon Managed Streaming for Apache Kafka cluster and configure the application services to use the cluster. Store static content in Amazon S3 behind an Amazon CloudFront distribution. D. Deploy the application on Amazon Elastic Kubernetes Service, Amazon EKS, with AWS Fargate and enable autoscaling behind an application load balancer. Create additional read replicas for the DB instance. Create an Amazon Managed Streaming for Apache Kafka cluster and configure the application services to use the cluster. Store static content in Amazon S3 behind an Amazon CloudFront distribution. A large payroll company recently merged with a small staffing company. The unified company now has multiple business units, each with its own existing AWS account. A solutions architect must ensure that the company can centrally manage the billing and access policies for all the AWS accounts. The solutions architect configures AWS organizations by sending an invitation to all member accounts of the company from a centralized management account. What should the solutions architect do next to meet these requirements? A. Create the organization account access IAM group in each member account. Include the necessary IAM roles for each administrator. B. Create the organization account access policy IAM policy in each member account. Connect the member accounts to the management account by using cross-account access. C. Create the organization account access role IAM role in each member account. Grant permission to the management account to assume the IAM role. D. Create the organization account access role IAM role in the management account. Attach the administrator access AWS managed policy to the IAM role. Assign the IAM role to the administrators in each member account. A solutions architect has deployed a web application that serves users across 2 AWS regions under a custom domain. The application uses Amazon Route 53 latency-based routing. The solutions architect has associated weighted record sets with a pair of web servers in separate availability zones for each region. The solutions architect runs a disaster recovery scenario. When all the web servers in one region are stopped, Route 53 does not automatically redirect users to the other region. Which of the following are possible root causes of this issue? Choose 2. A. The wait for the region where the web servers were stopped is higher than the wait for the other region. B. One of the web servers in the secondary region did not pass its HTTP health check. C. Latency resource record sets cannot be used in combination with weighted resource record sets. D. The setting to evaluate target health is not turned on for the latency alias resource record set that is associated with the domain in the region where the web servers were stopped. E. An HTTP health check has not been set up for one or more of the weighted resource record sets associated with the stopped web servers. A company runs an application in the cloud that consists of a database and a website. Users can post data to the website, have the data processed, and have the data sent back to them in an email. Data is stored in a MySQL database running on an Amazon EC2 instance. The database is running in a VPC with 2 private subnets. The website is running on Apache Tomcat in a single EC2 instance in a different VPC with 1 public subnet. There is a single VPC peering connection between the database and website VPC. The website has suffered several outages during the last month due to high traffic. Which actions should a solutions architect take to increase the reliability of the application? Choose 3. A. Place the Tomcat server in an auto-scaling group with multiple EC2 instances behind an application load balancer. B. Provision an additional VPC peering connection. C. Migrate the MySQL database to Amazon Aurora with 1 Aurora replica. D. Provision 2 NAT gateways in the database VPC. E. Move the Tomcat server to the database VPC. F. Create an additional public subnet in a different availability zone in the website VPC. A company has developed a new release of a popular video game and wants to make it available for public download. The new release package is approximately 5 GB in size. The company provides downloads for existing releases from a Linux-based, publicly facing FTP site hosted in an on-premises data center. The company expects the new release will be downloaded by users worldwide. The company wants a solution that provides improved download performance and low transfer costs, regardless of a user's location. A. Store the game files on Amazon EBS volumes mounted on Amazon EC2 instances within an auto-scaling group. Configure an FTP service on the EC2 instances. Use an application load balancer in front of the auto-scaling group. Publish the game download URL for users to download the package. B. Store the game files on Amazon EFS volumes that are attached to Amazon EC2 instances within an auto-scaling group. Configure an FTP service on each of the EC2 instances. Use an application load balancer in front of the auto-scaling group. Publish the game download URL for users to download the package. C. Configure Amazon Route 53 and an Amazon S3 bucket for website hosting. Upload the game files to the S3 bucket. Use Amazon CloudFront for the website. Publish the game download URL for users to download the package. D. Configure Amazon Route 53 and an Amazon S3 bucket for website hosting. Upload the game files to the S3 bucket. Set requester pays for the S3 bucket. Publish the game download URL for users to download the package. A global company has a mobile app that displays ticket barcodes. Customers use the tickets on the mobile app to attend live events. Event scanners read the ticket barcodes and call a backend API to validate the barcode data against data in a database. After the barcode is scanned, the backend logic writes to the database's single table to mark the barcode as used. The company needs to deploy the app on AWS with a DNS name of ap.example.com. The company will host the database in 3 AWS regions around the world. Which solution will meet these requirements with the lowest latency? A. Host the database on Amazon Aurora global database clusters. Host the backend on 3 Amazon Elastic Container Service (Amazon ECS) clusters that are in the same regions as the database. Create an accelerator in AWS Global Accelerator to route requests to the nearest ECS cluster. Create an Amazon Route 53 record that maps api.example.com to the accelerator endpoint. B. Host the database on Amazon Aurora Global Database Clusters. Host the backend on 3 Amazon Elastic Kubernetes Service, Amazon EKS, clusters that are in the same regions as the database. Create an Amazon CloudFront distribution with the 3 clusters as origins. Route requests to the nearest EKS cluster. Create an Amazon Route 53 record that maps api.example.com to the CloudFront distribution. C. Host the database on Amazon DynamoDB Global Tables. Create an Amazon CloudFront distribution. Associate the CloudFront distribution with a CloudFront function that contains the backend logic to validate the barcodes. Create an Amazon Route 53 record that maps api.example.com to the CloudFront distribution. D. Host the database on Amazon DynamoDB Global Tables. Create an Amazon CloudFront distribution. Associate the CloudFront distribution with a Lambda at Edge function that contains the backend logic to validate the barcodes. Create an Amazon Route 53 record that maps api.example.com to the CloudFront distribution. A company has a web application that uses Amazon API Gateway, AWS Lambda, and Amazon DynamoDB. A recent marketing campaign has increased demand. Monitoring software reports that many requests have significantly longer response times than before the marketing campaign. A solutions architect enabled Amazon CloudWatch logs for API Gateway and noticed that errors are occurring on 20% of the requests. In CloudWatch, the Lambda function throttles metric represents 1% of the requests, and the errors metric represents 10% of the requests. Application logs indicate that, when errors occur, there is a call to DynamoDB. What change should the solutions architect make to improve the current response times as the web application becomes more popular? A. Increase the concurrency limit of the Lambda function. B. Implement DynamoDB auto-scaling on the table. C. Increase the API Gateway throttle limit. D. Recreate the DynamoDB table with a better partitioned primary index. A company needs to improve the security of its web-based application on AWS. The application uses Amazon CloudFront with 2 custom origins. The first custom origin routes requests to an Amazon API Gateway HTTP API. The second custom origin routes traffic to an application load balancer ALB. The application integrates with an OpenID Connect OIDC identity provider IDP for user management. A security audit shows that a JSON Web Token JWT authorizer provides access to the API. The security audit also shows that the ALB accepts requests from unauthenticated users. A solutions architect must design a solution to ensure that all backend services respond to only authenticated users. Which solution will meet this requirement? A. Configure the ALB to enforce authentication and authorization by integrating the ALB with the IDP. Allow only authenticated users to access the backend services. B. Modify the CloudFront configuration to use signed URLs. Implement a permissive signing policy that allows any request to access the backend services. C. Create an AWS WAF Web ACL that filters out unauthenticated requests at the ALB level. Allow only authenticated traffic to reach the backend services. D. Enable AWS CloudTrail to log all requests that come to the ALB. Create an AWS Lambda function to analyze the logs and block any requests that come from unauthenticated users. A software as a service SAP-C company has developed a multi-tenant environment. The company uses Amazon DynamoDB tables that the tenants share for the storage layer. The company uses AWS Lambda functions for the application services. The company wants to offer a tiered subscription model that is based on resource consumption by each tenant. Each tenant is identified by a unique tenant ID that is sent as part of each request to the Lambda functions. The company has created an AWS cost and usage report, AWS KUR, in an AWS account. The company wants to allocate the DynamoDB costs to each tenant to match that tenant's resource consumption. Which solution will provide a granular view of the DynamoDB cost for each tenant with the least operational effort? A. Associate a new tag that is named Tenant ID with each table in DynamoDB. Activate the tag as a cost allocation tag in the AWS Billing and Cost Management console. Deploy new Lambda function code to log the tenant ID in Amazon CloudWatch logs. Use the AWS CUR to separate DynamoDB consumption cost for each tenant ID. B. Configure the Lambda functions to log the tenant ID and the number of RCUs and WCUs consumed from DynamoDB for each transaction to Amazon CloudWatch logs. Deploy another Lambda function to calculate the tenant costs by using the logged capacity units and the overall DynamoDB cost from the AWS Cost Explorer API. Create an Amazon Event Bridge rule to invoke the calculation Lambda function on a schedule. C. Create a new partition key that associates DynamoDB items with individual tenants. Deploy a Lambda function to populate the new column as part of each transaction. Deploy another Lambda function to calculate the tenant costs by using Amazon Athena to calculate the number of tenant items from DynamoDB and the overall DynamoDB cost from the AWS CUR. Create an Amazon Event Bridge rule to invoke the calculation Lambda function on a schedule. A. Deploy a Lambda function to log the tenant ID, the size of each response, and the duration of the transaction call as custom metrics to Amazon CloudWatch logs. Use CloudWatch logs insights to query the custom metrics for each tenant. Use AWS pricing calculator to obtain the overall DynamoDB costs and to calculate the tenant costs. A startup company recently migrated a large e-commerce website to AWS. The website has experienced a 70% increase in sales. Software engineers are using a private GitHub repository to manage code. The DevOps team is using Jenkins for builds and unit testing. The engineers need to receive notifications for bad builds and zero downtime during deployments. The engineers also need to ensure any changes to production are seamless for users and can be rolled back in the event of a major issue. The software engineers have decided to use AWS Code Pipeline to manage their build and deployment process. Which solution will meet these requirements? A. Use GitHub WebSockets to trigger the code pipeline. Use the Jenkins plugin for AWS Code Build to conduct unit testing. Send alerts to an Amazon SNS topic for any bad builds. Deploy in an in-place, all-at-once deployment configuration using AWS Code Deploy. B. Use GitHub webhooks to trigger the code pipeline. Use the Jenkins plugin for AWS Code Build to conduct unit testing. Send alerts to an Amazon SNS topic for any bad builds. Deploy in a blue/green deployment using AWS Code Deploy. C. Use GitHub WebSockets to trigger the code pipeline. Use AWS X-Ray for unit testing and static code analysis. Send alerts to an Amazon SNS topic for any bad builds. Deploy in a blue/green deployment using AWS Code Deploy. D. Use GitHub webhooks to trigger the code pipeline. Use AWS X-Ray for unit testing and static code analysis. Send alerts to an Amazon SNS topic for any bad builds. Deploy in an in-place, all-at-once deployment configuration using AWS Code Deploy. A company has an application that uses an Amazon Aurora PostgreSQL DB cluster for the application's database. The DB cluster contains one small primary instance and 3 larger replica instances. The application runs on an AWS Lambda function. The application makes many short-lived connections to the database's replica instances to perform read-only operations. During periods of high traffic, the application becomes unreliable, and the database reports that too many connections are being established. The frequency of high traffic periods is unpredictable. Which solution will improve the reliability of the application? A. Use Amazon RDS proxy to create a proxy for the DB cluster. Configure a read-only endpoint for the proxy. Update the Lambda function to connect to the proxy endpoint. B. Increase the max_connection setting on the DB cluster's parameter group. Reboot all the instances in the DB cluster. Update the Lambda function to connect to the DB cluster endpoint. C. Configure instance scaling for the DB cluster to occur when the database connections metric is close to the max connection setting. Update the Lambda function to connect to the Aurora Reader endpoint. D. Use Amazon RDS proxy to create a proxy for the DB cluster. Configure a read-only endpoint for the Aurora Data API on the proxy. Update the Lambda function to connect to the proxy endpoint. A solutions architect is preparing to deploy a new security tool into several previously unused AWS regions. The solutions architect will deploy the tool by using an AWS CloudFormation stack set. The stack set's template contains an IAM role that has a custom name. Upon creation of the stack set, no stack instances are created successfully. What should the solutions architect do to deploy the stack successfully? A. Enable the new regions in all relevant accounts. Specify the capability named IAM capability during the creation of the stack set. B. Use the Service Quotas console to request a quota increase for the number of CloudFormation stacks in each new region in all relevant accounts. Specify the capability IAM capability during the creation of the stack set. C. Specify the capability named IAM capability and the self-managed permissions model during the creation of the stack set. D. Specify an administration role ARN and the capability IAM capability during the creation of the stack set. A company is deploying a third-party web application on AWS. The application is packaged as a Docker image. The company has deployed the Docker image as an AWS Fargate service in Amazon Elastic Container Service, Amazon ECS. An application load balancer, ALB, directs traffic to the application. The company needs to give only a specific list of users the ability to access the application from the internet. The company cannot change the application and cannot integrate the application with an identity provider. All users must be authenticated through multi-factor authentication, MFA. Which solution will meet these requirements? A. Create a user pool in Amazon Cognito. Configure the pool for the application. Populate the pool with the required users. Configure the pool to require configure a listener rule on the ALB to require authentication through the Amazon Cognito hosted UI. B. Configure the users in AWS Identity and Access Management, IAM. Attach a resource policy to the Fargate service to require users to use MFA. Configure a listener rule on the ALB to require authentication through IAM. C. Configure the users in AWS Identity and Access Management (IAM). Enable AWS IAM Identity Center (AWS Single Sign-On). Configure resource protection for the ALB. Create a resource protection rule to require users to use MFA. D. Create a user pool in AWS Amplify. Configure the pool for the application. Populate the pool with the required users. Configure the pool to require MFA. Configure a listener rule on the ALB to require authentication through the Amplify hosted UI. A company is planning to migrate its business-critical applications from an on-premises data center to AWS. The company has an on-premises installation of a Microsoft SQL Server, always on cluster. The company wants to migrate to an AWS managed database service. A solutions architect must design a heterogeneous database migration on AWS. Which solution will meet these requirements? A. Migrate the SQL Server databases to Amazon RDS for MySQL by using backup and restore utilities. B. Use an AWS Snowball Edge storage optimized device to transfer data to Amazon S3. Set up Amazon RDS for MySQL. Use S3 integration with SQL Server features such as bulk insert. C. Use the AWS Schema Conversion tool to translate the database schema to Amazon RDS for MySQL. Then use AWS Database Migration Service (AWS DMS) to migrate the data from on-premises databases to Amazon RDS. D. Use AWS DataSync to migrate data over the network between on-premises storage and Amazon S3. Set up Amazon RDS for MySQL. Use S3 integration with SQL Server features such as bulk insert. A company is deploying AWS Lambda functions that access an Amazon RDS for PostgreSQL database. The company needs to launch the Lambda functions in a QA environment and in a production environment. The company must not expose credentials within application code and must rotate passwords automatically. Which solution will meet these requirements? A. Store the database credentials for both environments in AWS Systems Manager Parameter Store. Encrypt the credentials by using an AWS Key Management Service (AWS KMS key). Within the application code of the Lambda functions, pull the credentials from the parameter store parameter by using the AWS SDK for Python, Bodo 3. Add a role to the Lambda functions to provide access to the parameter store parameter. B. Store the database credentials for both environments in AWS Secrets Manager with distinct key entry for the QA environment and the production environment. Turn on rotation. Provide a reference to the Secrets Manager key as an environment variable for the Lambda functions. C. Store the database credentials for both environments in AWS Key Management Service, AWS KMS. Turn on rotation. Provide a reference to the credentials that are stored in AWS KMS as an environment variable for the Lambda functions. D. Create separate S3 buckets for the QA environment and the production environment. Turn on server-side encryption with AWS KMS keys, SSE-KMS, for the S3 buckets. Use an object naming pattern that gives each Lambda function's application code the ability to pull the correct credentials for the function's corresponding environment. Grant each Lambda function's execution role access to Amazon S3. A company needs to implement a disaster recovery (DOCTOR) plan for a web application. The application runs in a single AWS region. The application uses microservices that run in containers. The containers are hosted on AWS Fargate in Amazon Elastic Container Service, Amazon ECS. The application has an Amazon RDS for MySQL DB instance as its data layer and uses Amazon Route 53 for DNS resolution. An Amazon CloudWatch alarm invokes an Amazon Event Bridge rule if the application experiences a failure. A solutions architect must design a DR solution to provide application recovery to a separate region. The solution must minimize the time that is necessary to recover from a failure. Which solution will meet these requirements? A company is preparing to deploy an Amazon Elastic Kubernetes Service, Amazon EKS, cluster for a workload. The company expects the cluster to support an unpredictable number of stateless pods. Many of the pods will be created during a short time period as the workload automatically scales the number of replicas that the workload uses. Which solution will maximize node resilience? A. Use a separate launch template to deploy the EKS control plane into a second cluster that is separate from the workload node groups. B. Update the workload node groups. Use a smaller number of node groups and larger instances in the node groups. C. Configure the Kubernetes cluster autoscaler to ensure that the compute capacity of the workload node groups stays under-provisioned. D. Configure the workload to use topology spread constraints that are based on availability zone. A software company hosts an application on AWS with resources in multiple AWS accounts and regions. The application runs on a group of Amazon EC2 instances in an application VPC located in the US East 1 region with an IPv4 CIDR block of 10.10.0.0/16. In a different AWS account, a shared services VPC is located in the US East 2 region with an IPv4 CIDR block of 10.10.10.0/24. When a cloud engineer uses AWS CloudFormation to attempt to peer the application VPC with the shared services VPC, an error message indicates a peering failure. Which factors could cause this error? Choose 2. A. The IPv4 CIDR ranges of the two VPCs overlap. B. The VPCs are not in the same region. C. One or both accounts do not have access to an internet gateway. D. One of the VPCs was not shared through AWS Resource Access Manager. E. The IAM role in the peer acceptor account does not have the correct permissions. A company runs a web application on AWS. The web application delivers static content from an Amazon S3 bucket that is behind an Amazon CloudFront distribution. The application serves dynamic content by using an application load balancer, ALB, that distributes requests to a fleet of Amazon EC2 instances in auto-scaling groups. The application uses a domain name setup in Amazon Route 53. Some users reported occasional issues when the users attempted to access the website during peak hours. An operations team found that the ALB sometimes returned HTTP 503 service unavailable errors. The company wants to display a custom error message page when these errors occur. The page should be displayed immediately for this error code. Which solution will meet these requirements with the least operational overhead? A. Set up a Route 53 failover routing policy. Configure a health check to determine the status of the ALB endpoint and to failover to the failover S3 bucket endpoint. B. Create a second CloudFront distribution and an S3 static website to host the custom error page. Set up a Route 53 failover routing policy. Use an active-passive configuration between the two distributions. C. Create a CloudFront origin group that has two origins. Set the ALB endpoint as the primary origin. For the secondary origin, set an S3 bucket that is configured to host a static website. Set up origin failover for the CloudFront distribution. Update the S3 static website to incorporate the custom error page. D. Create a CloudFront function that validates each HTTP response code that the ALB returns. Create an S3 static website in an S3 bucket. Upload the custom error page to the S3 bucket as a failover. Update the function to read the S3 bucket and to serve the error page to the end users. A delivery company is running a serverless solution in the AWS cloud. The solution manages user data, delivery information, and past purchase details. The solution consists of several microservices. The central user service stores sensitive data in an Amazon DynamoDB table. Several of the other microservices store a copy of parts of the sensitive data in different storage services. The company needs the ability to delete user information upon request. As soon as the central user service deletes a user, every other microservice must also delete its copy of the data immediately. Which solution will meet these requirements? A. Activate DynamoDB streams on the DynamoDB table. Create an AWS Lambda trigger for the DynamoDB stream that will post events about user deletion in an Amazon Simple Queue service, Amazon SQS-Queue. Configure each microservice to pull the queue and delete the user from the DynamoDB table. B. Set up DynamoDB event notifications on the DynamoDB table. Create an Amazon Simple Notification Service, Amazon SNS topic, as a target for the DynamoDB event notification. Configure each microservice to subscribe to the SNS topic and to delete the user from the DynamoDB table. C. Configure the central user service to post an event on a custom Amazon Event Bridge event bus when the company deletes a user. Create an event bridge rule for each microservice to match the user deletion event pattern and invoke logic in the microservice to delete the user from the DynamoDB table. D. Configure the central user service to post a message on an Amazon Simple Queue service, Amazon SQS-Queue, when the company deletes a user. Configure each microservice to create an event filter on the SQS-Queue and to delete the user from the DynamoDB table. A company used Amazon EC2 instances to deploy a web fleet to host a blog site. The EC2 instances are behind an application load balancer, ALB, and are configured in an auto-scaling group. The web application stores all blog content on an Amazon EFS volume. The company recently added a feature for bloggers to add video to their posts, attracting 10 times the previous user traffic. At peak times of day, users report buffering and timeout issues while attempting to reach the site or watch videos. Which is the most cost-efficient and scalable deployment that will resolve the issues for users? A. Reconfigure Amazon EFS to enable maximum IOB. Update the blog site to use instant store volumes for storage. Copy the site contents to the volumes at launch and to Amazon S3 at shutdown. C. Configure an Amazon CloudFront distribution. Point the distribution to an S3 bucket and migrate the videos from EFS to Amazon S3. D. Set up an Amazon CloudFront distribution for all site contents and point the distribution at the ALB. A company has automated the nightly retraining of its machine learning models by using AWS step functions. The workflow consists of multiple steps that use AWS Lambda. Each step can fail for various reasons, and any failure causes a failure of the overall workflow. A review reveals that the retraining has failed multiple nights in a row without the company noticing the failure. A solutions architect needs to improve the workflow so that notifications are sent for all types of failures in the retraining process. Which combination of steps should the solutions architect take to meet these requirements? Choose 3. A. Create an Amazon Simple Notification Service, Amazon SNS, topic, with a subscription of type email that targets the team's mailing list. B. Create a task named email that forwards the input arguments to the SNS topic. C. Add a catch field to all task, map, and parallel states that have a statement of error equals states, all, and next, email. D. Add a new email address to Amazon Simple Email Service, Amazon SES. Verify the email address. E. Create a task named email that forwards the input arguments to the SES email address. F. Add a catch field to all task, map, and parallel states that have a statement of error equals states, runtime, and next, email. An enterprise company is building an infrastructure services platform for its users. The company has the following requirements. Provide least privilege access to users when launching AWS infrastructure, so users cannot provision unapproved services. Use a central account to manage the creation of infrastructure services. Provide the ability to distribute infrastructure services to multiple accounts in AWS organizations. Provide the ability to enforce tags on any infrastructure that is started by users. Which combination of actions using AWS services will meet these requirements? Choose 3. A. Develop infrastructure services using AWS CloudFormation templates. Add the templates to a central Amazon S3 bucket, and add the IAM roles or users that require access to the S3 bucket policy. B. Develop infrastructure services using AWS CloudFormation templates. Upload each template as an AWS Service Catalog product to portfolios created in a central AWS account. Share these portfolios with the organization structure created for the company. C. Allow user IAM roles to have AWS CloudFormation full access and Amazon S3 read-only access permissions. Add an organization's SCP at the AWS account root user level to deny all services except AWS CloudFormation and Amazon S3. A. Allow user IAM roles to have Service Catalog and user access permissions only. Use an automation script to import the central portfolios to local AWS accounts. Copy the tag option, assign users access, and apply launch constraints. A. Use the AWS Service Catalog tag option library to maintain a list of tags required by the company. Apply the tag option to AWS Service Catalog products or portfolios. F. Use the AWS CloudFormation Resource Tags property to enforce the application of tags to any CloudFormation templates that will be created for users. A solutions architect must create a business case for migration of a company's on-premises data center to the AWS cloud. The solutions architect will use a configuration management database (CMDB) export of all the company's servers to create the case. Which solution will meet these requirements most cost-effectively? A. Use AWS well-architected tool to import the CMDB data to perform an analysis and generate recommendations. B. Use Migration Evaluator to perform an analysis. Use the Data Import template to upload the data from the CMDB export. C. Implement resource matching rules. Use the CMDB export and the AWS price list bulk API to query CMDB data against AWS services in bulk. D. Use AWS Application Discovery Service to import the CMDB data to perform an analysis. A company hosts an application on AWS. The application reads and writes objects that are stored in a single Amazon S3 bucket. The company must modify the application to deploy the application in 2 AWS regions. Which solution will meet these requirements with the least operational overhead? A. Set up an Amazon CloudFront distribution with the S3 bucket as an origin. Deploy the application to a second region. Modify the application to use the CloudFront distribution. Use AWS Global Accelerator to access the data in the S3 bucket. B. Create a new S3 bucket in a second region. Set up bidirectional S3 cross-region replication (CRR) between the original S3 bucket and the new S3 bucket. Configure an S3 multi-region access point that uses both S3 buckets. Deploy a modified application to both regions. C. Create a new S3 bucket in a second region. Deploy the application in the second region. Configure the application to use the new S3 bucket. Set up S3 cross-region replication (CRR) from the original S3 bucket to the new S3 bucket. D. Set up an S3 gateway endpoint with the S3 bucket as an origin. Deploy the application to a second region. Modify the application to use the new S3 gateway endpoint. Use S3 intelligent tiering on the S3 bucket.